It has become personal. I must finish this stupid skull speaker project because it's distracting me from everything else that I need to get done. But lucky for us, the LM386 exists. It's a much simpler circuit. So we'll kick this off in just a bit. And the only hard part is going to be putting a chip through this thing. But I'll have to pull all the capacitors and all the other components off because I don't know what went wrong. I do not know. I did not find any answers yesterday. Yesterday I just simply did research on the LM386, which I have in that kit, in that through-hole kit. This is what happens when I touch my hair before it dries. It'll dry in a weird way, and it won't go back to like normal. I need to get a haircut. I need a haircut. That's the bottom line. Where is my OBS? Yeah, there's my OBS. All right, so all my audio is sparkling. Everything's pretty good. We got the FTL soundtrack going. I have that chat there. I have Twitch chat over there. Nightbot, the last thing Nightbot said was undefined. It literally just said undefined into my chat. I don't know what that's all about. And 0 viewers across every platform. Beautiful, beautiful. Oh no, we got 5 on Twitch. All right. Just gotta come in here and ruin the moment. Refresh. Streamlabs. My birthday tomorrow. Kind of a big one, too. Let's see. Celia Russell stuff was the last thing that happened. All right, here we go. Yeah, I think I'm all set up. Got windows on windows on windows. I need another monitor up here. Up in this beast. Why is Fusion 360 still running? I'm gonna close that. We need to do something where we like design something that gets 3D printed. People always find that kind of interesting. Synthesizer stuff has been kind of a big deal lately. This is the low quality. Is it just my? Yeah, it's showing my stream at 480p. Sweet 16 again. Sure. Sure. Won't you please donate so that the streamer can get a real haircut? Stupid. My hair is not cooperating. It's getting to a length where by the end of the day it starts hurting. Like, I don't know what that's all about. I think it's just the volume of my hair pulling on my scalp that I'm not used to. And I know everybody's like, oh, boo-hoo, I don't even have hair. I'm like, look, I can't help you people. I have my own problems. I want to get back to the modules, because, like, the synthesizer's in kind of a sorry state. Wayne Johnson gifted a sub and it went to Denethal, of all people. Thank you, Wayne Johnson. You don't ever... I know it's fun for a bit, but like if I feel bad when people respond to me making fun of desperate begging streamers, because I don't need it. You guys don't need to send it, but I appreciate it very much, and I'm glad I went to Demithel too, because Demi's always in here. Demi lets his daughter type on the keyboard, and she starts sending emotes, and it's absolutely the cutest thing. But yeah, this is the state of the synthesizer. I have 1, 2, 3 things that are designed to create control voltages, and an ADSR that I haven't even tested. So all of the other modules that are sitting basically under that piece of paper over there, and sitting on the desk in various little cubby holes. I need to finish, like, getting them running and make sure they work. That way I can actually, you know, play the synthesizer. I can actually, like, start making the circuits together and stuff. I mean, the interesting part was doing all the soldering. That was the part that I was the best at. And I kind of blew through all of that work, and now it's just troubleshooting and testing, which, again, that is all part of the electrical engineering. You know, it's inside the purview of what us EEs need to be able to do. It's just annoying. It's just annoying, that's all. These have been very frustrating circuits overall. They are sparse on the details, which is what I signed up for, and they require you to basically vet out every single facet of the design. Hey, what's up, Turby? How's it going? What's up in this corner of the internet? I am on the precipice of a very large birthday. Not in terms of scope, but in terms of the number that I become. I'll probably stop bitching about it soon. But anyway, yeah, oh, I shouldn't curse in the beginning of a YouTube video. I'm also co-streaming to YouTube. I've got a little VOD channel that I pulled up, and I need to start uploading to the VOD channel. Yeah, I'm finally 70 years old. It happened. It happened kind of suddenly, jumping from 39 to 70, but it happened. And that's how the internet sees you, right? As soon as you turn 30, you're basically dust on a grave. I have a feeling this chip still works, but I'm gonna throw it out because these didn't work. They didn't function. I think it may have just been the diodes breaking, the old diodes that I used from an old power supply. That probably the reason the power supply ended up on the healing bench is that the bridge rectifier exploded. I don't really know diodes to fail all that often, but I mean, usually, like, if you're handling them, oh, I just threw one out. If you're, like, bending the leads on them again, maybe that happens. Kids Corner Shop treat you like you have a walking cane and gray hair with shaking hands. Jeez. Hey, just stay out of those spaces. Don't you have that restraining order in effect? I don't really interact with kids all that much. My niece was here a little while ago, and she was playing Pokemon, and I'm like, oh, I love Dead End because he uses RF, and she just looked at me like I had two heads. I'm like, what? You're playing Pokemon, what? Am I not allowed to know anything about it? I was there when the books were written 10,000 years ago. This is kind of a boring part of the soundtrack. Hold on, I'm gonna pop it forward a little bit. Let's just pop it forward a little bit. Kind of the open space part of the soundtrack. Go somewhere where there's actually notes playing. There we go. I can beat your party with Gen 1 Pokemon. I always loved, like, a billion years ago when previously recorded Jack and Rich from Red Letter Media did a Pokemon playthrough. And Rich simply always just hit the A button. That was his whole strategy, hit the A button. 3. What are you doing? What are you doing over there? YouTube! I'm not paying attention to you. You're just doing that to annoy me. Yeah, he only hit the letter A and was basically beating Gen 1 that way. It was great. Oh, okay, hair is not happening today. I should wear a hat. I don't have a hat. Yeah, Burn the Subs is looming on the horizon. I need to work on that again, but I want to get more stuff done with the synthesizer. I want that to be a thing that I can use. I want it to actually function. So there's a lot more troubleshooting to go. And this is just part of it. This is just part of the troubleshooting, is the skull speaker. Simply because this allows me to listen in on what I'm doing without having to wear headphones. Then I don't get a gamer dent in my skull. We finished Cursed Halo last night. Finally, there was a big hiatus in playing it. We played through most of it. Is that a Hat in Time hat? I think it is. It's just a top hat emoji, but it's got a purple band, so it's a hat in time. But yeah, we played a bunch of it, and then there was a gap, and during that gap, a bunch of stuff was added to Cursed Halo, and it took us forever to get it running again. The Master Chief Collection is the most heinous UI I've ever seen in a AAA game ever. In order to install and uninstall the games, you have to go into the settings, go to the gameplay menu, and then click another button in order to see what you've installed. And then you can add and delete stuff. And for some reason, it had deleted my multiplayer Halo. Halo CE, the original edition multiplayer, was uninstalled. And I didn't uninstall it. I don't even know how to get into the menu. Utter ridiculousness. But that took us a good half hour of troubleshooting. Then on top of it, my mixer is doing gated audio, and so is Discord, because Discord, again, another one of these programs that monkeys around with the settings when you're not paying attention. Oh, Discord updated, and we redid all of your settings so that you have more audio filters active. And I'm like, stop it. Very specifically turned everything off. I need to figure out how I can get my activity to trigger on voice and not turn it up and down. Because when I talk, like, if I'm in the sweet spot of the mic, it's super hot, it's super loud, and it's super crisp. It's really good audio, right? But if I'm just a little bit outside of that sweet spot, it drops off almost immediately. And what that ends up causing is it sounds like there is somebody with a volume knob turning me up and down when I go to talk. Yeah, Cursed Halo is really fun. It's made by somebody who loves Halo, and you can tell they know all the ins and outs of the original Halo by the type of humor and the type of things that they do, and yeah, it's just really good. I'm gonna reorganize my resistors. We've come to that. It's come to that. I have to do this. Otherwise I won't be able to sleep at night. We're starting at the lowest of the low. That's 1R5. Where's my 1 ohm? That's 10 ohms. There was 1 ohm, we used it. Is this just like creepy music? What's going on in the background here? What happened to my music? 150, 75. Most of these are kind of in order. It's just the ones where I've taken away resistors that aren't organized. So 1 ohm is somewhere around here. What is this one? This one's just like... It's uncategorized. There's no value on it. Dun dun dun. Alright, put that over there. That needs to be figured out. That's 10M. 2M, 4.7M. We had 1R. We used it. I used it on the Skull speaker and it exploded. Yeah, this is it's become personal with the Skull speaker. I feel like I just failed badly, so I need to go back to the Skull speaker and actually make it work, because I'm mad now. I didn't mean for it to be a 3-stream project, but here we are. We have a pretty bookstore. What, you want me to use the Dewey Decimal System on my resistors? Alright, well, let's just start. I'm looking for 1 ohm. I know I have it. It's 100 ohms. 1.5K. 5.6M. 22, 68, 32 height. 3.3K. Alright, so just going in order. 7.5, 8.2, 10, and I guess 1 will show up somewhere. 10, 15. Actually, yeah, that would be kind of nice, is to have like a little card catalog drawer, and then these could just go in there. Yeah, that would be nice. Thank you for the follows. 15, 22, 27. These will mostly be in order. I'm just gonna kind of stack them back in here, and then I'll add in the ones that I find along the way. The resistors were the friends we made along the way. 33, 39, 47, 56. Father, hasn't the stream started? Why would stream start be up if you're organizing resistors as part of your stream? 68. The answer to that question, if you were wondering, is I can do whatever I want. Better would be a floppy disk storing thing. 58, 75. Because then you get nerd cred. Ooh, 82 is not in good shape. We'll just put this in here and try to ignore it. It's bad that I've taken resistors from the labeled end. You know, if people implanting magnets into their finger, I wonder if I can get something that senses the value of a resistor implanted into my body. So I can just go like this and know what the resistor is. What's up, Robotech? That would be the most useful thing. Like, why don't your stuff labeled? We don't need labels. I'm RoboCop. 150, 180. These are not in good shape. I could probably do with trimming the ends and then put the label in the middle or something. Because, yeah, all the disorganization comes from the cut tape not fitting on top of itself. 180, 220, 270. Look at all these resistors. These packs are like $10. Some people flip tarot cards for fun. Bother flip stacks of resistors. I'm flipping stacks, yo. 330. So, Julian's Marbles is in the mail on the way to him. 330, 390. Yeah, you can do that with an RGB sensor. You could do an RGB sensor with a pretty bright light, and it would go in there and read them. But I mean, some of these are, well, they're blue, and so the colors are kind of hard to interpret. I hate the color resistor pattern. I hate it. I hate it. I hate everything about it. I love surface mount because it just has the value of the resistor printed on it. Simple. What I've seen on Hackaday, at least, I saw somebody make a little stand out of Lego, and then the little Lego man's hands, he put like conductor on them so that you take the resistor and you put it in the Lego man's hands, and it'll tell you the value of the resistor on a little screen below. I think it was just a number display. 470, 680, 820. So it better be above 820. 510 goes back here. Okay. So after 820, this one's 100 ohms. 56. 80 something, 75, 82, 120, so this goes here. These audio projects have really stressed my supplies of stuff. These are K, kiloohms, kiloohms, kiloohms. 1M. So I guess we got to start the next stack somewhere. There's 1R. That one's easy to put back. Yoink. There you go. So 820, so then let's jump to 1K. Although 1K is in these, the big ones, the ones I've had to reorder. Could you get the color back? No, that, because sometimes you get like old resistors. I was thinking like if you were always using the same tan resistors, you could get the color settings off of the tan color. But I mean, the Roy G. Biv should be far enough apart that you wouldn't have too much issue. 4R7, 4.7 ohms. It's way down here. Seven. What's next after 820? 1.5. And then we're going through the low values, so we have 2K2, 20K, 2M, 180K, that's a big one. A big one. I think we're doing these now. 3K3, 2K2, 3K3, K9, 8K. That's a weird British way of doing putting the K in there instead of a comma. Or just R. It's a strange shortcut. Hackaday is an article from 2015 of an Android app. Oh, that works. Hackaday is everything, man. That tip line is crazy. This one's 15K, and I wrote fuck after it. I don't know why. 22K. We can't be out of the single value kilo ohms. There's 2R2. R2. That one's only. Oh, here we go. 5.6. Okay, so 2R2 goes all the way back here. So actually that goes before that. 2R2, 4R7, then 5R6. Then it goes to 7, whatever. Starting to fill it in. This was an organizational task that I did not expect to be doing right now. I took it upon myself. 2M, 180K, 5.6. It goes in here. There, and there. Oh my god. Where does it end? 3M3. 1M. What are you? 10M. Okay, so I think we're making a jump in value here suddenly. So 8K. I mean, it's weird. I think 10K is something that I had to reorder. Yeah, the resistor organizing stream, I know. Who bothers the professor from Futurama? Yeah, I built a spaceship out of these wires that I had in this drawer. Also the result of time travel inbreeding. Huh? Or M7. Okay, what's the next value to go in here? I mean, I guess we don't have 10K, so we're going from 8K to 22K. That seems like a bit of a jump. 22 to 33. 39. 47. There's a big gap in there. Oh, 5.6K. All right, well, that explains some of the gap. This is where I've taken them out and they've become disorganized. Oh, 56. Wait a minute, that's not 5.6, it's 56. Why do they have them in those weird jumps? 47, 56, 68. Yeah, why not like 40, 50, 60, etc.? Yeah, the 10K are so frequently used that I've had to reorder them, and they then come in this giant piece of tape. 82. 82, 180. I don't think 100. I don't think I have 100 in these. I think 100 is another value that I've had to reorder. 4M7. 15K never found a space. Right there. 15. Where are we? We're at 180. This is 150. 50, 80. Color coding bedlam. It's a mess. It's a total mess. That's why I'm doing this. I need it to be organized. I need this for me. It's like I can't concentrate until I do this. We're almost done. Plus, this is just the time before stream starts. But bother, you're here. I always get those comments. There's always somebody who just doesn't know. Hey, Celia, how's it going? My daughter was 6. She was going to help me, so she pulled all the resistors out of the paper strips and put them in a jar that was too small for me to get my hand into. Oh, no. That's when you do what my brother used to do to me. We would start... I thought oh, my older brother wants to do something today with me. So I get to spend the whole day with my brother. It's so cool. And he goes, let's organize the Lego. And so we dump all the Lego onto the floor, and we get a bunch of bins, and we start organizing. And then my brother's friend, his mom, and my brother's friend come and pick him up because he's actually going over to a friend's house that day. And he left me with a big pile of Lego that was completely disorganized. I just put it all back in the bin. But still, he just like started this task that would have been really fun for the both of us to do, and then just left. This is 560, 680. Through-hole resistors just bring me flashbacks from the resistor waifu pillow with the backside of bare copper wire. Now, if you're gonna get one of those documentary, whatever they're called, might as well make it stupid like that. All right, we are at 680K. That brings us to the mega ohms. We start with 1M. 1M. Then we go to... Do I have 2M? Yeah, there we go. 2M, 3M3, 3M3. Oh, 1M5 actually goes in here. 1M5, 2M2, 3M3, 4M7, 5M6, 10M. Done. That's as organized as they get. I don't know what this one is. I don't know what it is. So that'll just go like that. We're gonna be using these today, so this is what it's come down to. Yeah, see, there's 100K. They're used so often that I had to reorder them. Nice and organized. That resistor poking out of the bin really kind of punctuates it, huh? Does it close? Listen. I don't need your sass. I don't need that today. I don't need that today. I mean, what? Yeah, the reason that I bring up my brother's leaving me with the task of organizing on that is like, if your daughter put all the resistors into a jar, sit her down with a multimeter, and let's say here's a bunch of smaller bins, and you're gonna put all the resistors into those bins. Here's a multimeter. Don't poke yourself hard enough to bleed. Doing that with the multimeter would be really annoying, though. I mean, it would be better to like the Lego man, I don't know, put the multimeter in a vise so you can just drop the resistor down and get a value. But then you need to put a little pressure on it in order for it to actually work. So, I don't know. Yeah, but like, what are you gonna do? Pogo pins? You could like make a factory like an automated process for it. Although, how would you route them from there? That's getting into some crazy stuff. Let's turn these on just so that they're in the background flashing. The simple answer to the refrigerator light. The refrigerator light is an easy problem, and I don't know why any refrigerator still has a lever switch when read relays exist. You would just put a read relay behind the plastic and put a magnet in part of the door. So you close the door, it sets off the read relay. Or you could do it with a solid state thing. That would be cheaper than having a physical switch. But a lot of them have, I don't know, maybe they have a spring piece of plastic, and then it'll have that inside. I don't know. What's up, Brink? Woke up to messages from my coworkers that our server room's AC is leaking water on the server rack. Why was it set up in a position to do that? Why is that even a possibility? What the hell? I mean, I know you need extra refrigeration on a server, but like, duct exists. I have a missed call and a visual voicemail. Hold on. Watch it be political. What medication is Lucia? Is that... Lucy's, and it's year, and it's time to get your shot of Lucia. I think the phone's trying to type things, and it's getting it wrong. Who's your brother? He wants to hang out. My brother doesn't call. We barely contact each other. Although, you know, it's not like we're not friendly. We're perfectly friendly with each other. He's just a very busy guy. I should call him. Yeah, that was something about getting a flu shot, which I do need to do. I have not done that. Bad. Real bad. I'm gonna get my ass fucking kicked by COVID if I get it. Enzymes which use luciferases are the bioenzymatic method of glowing. See, I read the bottom comment first, and I thought you were making a vaccine joke, which are so tired at this point. But you weren't. You were actually citing the name of... That's so weird. I think what it was is flu season, and for some reason it translated that to Lucy. Never be in the dark again. I'm glowing. AC is a mini split in the ceiling. Water's dropping from a condenser like 6 feet away to the actual mini split. I just like, if that's a possibility that water would drip on your servers, wouldn't it be prudent to just not just not do that? Just like make it a different way. I don't know. That's crazy. It's a horror story. Hopefully they found plastic to put somewhere or redirect it. Find a bucket. It got cold here. It's finally like we finally got cold weather. I think it might just be a snap. We might be up to normal temperatures soon. But it was nice to have an actual like cool Halloween for once. Halloween's usually kind of cool in the Northeast. It can vary. It can be a little warm, but it was like hot last Halloween, I remember. Yeah, air feeding into the center under the floor. It would be because like you do. Is it down or up? I forget what the direction is, but you have the raised floors, and then you have AC coming in the raised floors and getting piped up through the servers, and then out. I think it could be the other way around. I don't know. But I mean, just having like a ceiling AC unit and a server rack directly beneath it, I wouldn't even start that way. I wouldn't want that. It would be better to get one of those standing AC units with ducts. You just put one up on the server rack and the other one out the windows. Releasing the space, you can get a choice. Ah, yes. Yeah, that would be the Home Depot bucket special then. The drip bucket. Out and warm air gets sucked out at walls at ceiling. So the walls and the ceiling are removing the warm air, and then AC goes in through the floor. Okay. That's the way to do it. But heat sinks. If heat rises, why do heat sinks? What are heat sinks? So I guess these resistors stay, these resistors stay, kind of. They're not really necessary in the circuit. They will limit the maximum volume. And then this stays, all this goes. This cursed nonsense. The rack isn't under the AC directly, it's 6 feet to one side, which is where there's an elbow in the condenser line in the drop ceiling. Oh my god. Yeah, do an FTL. FTL's great. It's a good soundtrack. I don't think it'll get me in prison for my crimes of playing music at the beginning of my stream, but you never know. FTL was a long time ago, wasn't it? Creator of FTL's already released another game, but it was nothing like FTL. Wasn't FTL basically a soundtrack in search of a game? Maintenance is already there and the server killed. It's just a build server. Oh my god. That's wild. One elbow and a pipe was all it took. That's like the worst nightmare of an IT person. Absolute worst. Man, I'm tired. I'm tired of these. I'm tired of this setup. I'm tired of these modules. I gotta keep going though. I have to produce a synthesizer. And I bought just circuit boards. A lot of work because you're dealing with a lot of other people's design philosophy. Everybody does something a little differently, and that was sort of the part of the cornerstone of my career with all that IED stuff, is that everybody builds something a little bit differently. If you ask two engineers to make a light switch, they're going to create just completely like juxtaposed designs just because they do things the way they do things, and that leads to some differentiation in sort of the creative process of engineering. So going through and vetting out a bunch of other people's designs has really put me into it's a lot of work is what I'm trying to say. It's crazy. It's a lot of work. You got to kind of get to all the little things that go wrong. Yeah, well, it's easy to stay in the realm of like the movie critic, where you're looking at everything's flaws and you're concentrating on all the flaws, but in doing so, you're sort of closing yourself off from learning sort of some of the design philosophies of the people who build these different modules. And you get to know them, and you get to know how they do stuff, and that's where you really grow. You know, I always say you should do projects that are a little bit out of your comfort zone. It should scare you just a little bit, and in doing so, you grow. You challenge yourself. And so my troubleshooting ability on analog circuitry is being directly challenged on all these things. This 4046 VCO, I put this all together in like a couple days. It was a couple days of work. I had to order some parts that took a little while to get here. And now I've got this big bundle of wires connecting the front panel to the circuit board. And it's through hole. It should be easy as can be. but when I plug it in, I get a negative 15 volt triangle wave. I'm only giving this thing plus and minus 12 volts. How did I get to negative 15? How does that work? Ghosts. It's ghosts. It's the doing of ghosts, and it scares me. I don't know why that does that. So I'm gonna have to bust this thing open again and vet out each individual connection to figure out what I did wrong. It's probably one of the assumptions that I made about this panel here. I'm probably grounding something that shouldn't be grounded. It's free energy. I've finally done it. Move over, Fusion. We have weird circuitry that doesn't work right. Then this right here is actually a perfectly functioning stereo speaker. Not stereo, sorry, mono speaker. Perfectly functioning. It works great. I'm not using it. What is their amplifier chip? I wonder. What is their amplifier chip? Yeah, the better YouTube debut probably would have been soldering stuff. You know, when I was building the circuit board, it's kind of a better impression. I saw this thing where they had a ring light where you could turn on the different locations of the ring in order to better illuminate. I gotta stand up and look at that. HT869, HT869 1R. HT869 1R. Yoink. Audio power amplifier with boost. 11-watt continuous power into a 2-ohm speaker. Heroic Electric Tech. There you go. Anti-clipping, filter-less modulation, 5.5 watts. Ohm. We have a 4 ohm. Is that a puppy I heard? Where's that puppy? Oh, there's a sunbeam. That sunbeam goes directly on my computer, which is bad because of water cooling. I can get algae. Also, that fluff is over there for, it's the dog. She had a toy that she tore apart. Oh yeah, I love the applications that they list. iPhone, iPod, iPod docking, 2.1 channel speakers, Bluetooth speakers, portable speakers, megaphone, MP4 GPS, smartphones, portable gamers. Gamers generally are not that portable though. They don't really like to move around that much. That's why they all buy racing chairs. Anti-clipping. Filterless modulation. So that's the circuit. That's a lot of extra hardware. This is the surface mount chip that's in the original speaker. I could actually get this out and then use that, but I'd have to make like a copper tape circuit for it. MP4/GPS. Yeah, what does that imply? Wait a minute, what does that imply? I can't make a joke because the correlations between MP4 and GPS, they're two circles on the Venn diagram. It's two circles that are 6 feet apart. Like, what the heck? Weird. Maybe for GPS voice, but that should be its own category. Why would it be MP4/GPS? I don't. Maybe playback is what they're trying to imply. Or maybe we just don't read into it. They're just both 3-letter acronyms. This one has a central ground that I wouldn't really be able to get to. I guess, but then why put MP4 with that? I mean, yeah, I know they play MP4s, but that's thinking too far into it. Boost converter voltage, 7.8 volts? It's too few volts for us. It's a weird voltage, though. this about the boost converter in here. All right, well, anyway, we're not using this chip. We're going to be using output impedance, Z out, former source circuit, signal path, in plus, in minus terminal. Huh. I don't think this thing will get to RF frequencies. That would be funny if it did. Yeah, we use this audio chip. It's got clipping protection for our 10 gigahertz excessive inputs. Interesting. So yeah, instead of letting it clip, it'll reduce its gain with an attack and a decay. Ooh, those are long. 50 milliseconds and 64. Those are long. Test circuit! Yeah! Okay, well, that's what that chip that's already on there is. We could use this if we really want to. I don't know if I have all these parts. The coil would be the hardest thing. Well, DX, it doesn't even give me a label for it. I have to figure that one out. Control pin, I don't know what you do with that. Is there like a volume on this thing? No, so you'd have to have a pot in there. And you have these two here. RD2, I have to calculate. RD1 and 2, okay. That's a feedback, I guess. 1 ohm, what value is this coil? 1 ohm resistor. 1 ohm resistor, really? And then some kind of a coil right there. I don't know what that coil is. Again, it's probably something you need to calculate. We technically have all the parts, but they're all surface mount. They're all already on here. They are. Here's the coil. So I could just like feel this. But then the power supply is much smaller. We need a regulator on the 12 volt incoming. I don't really want to do. I don't want to have a regulator in there, zapping all my current. Let's get rid of start soon, so I can actually start soon. Let's start the stream. Where's my volume control? I don't know. I lost the window. It's like, okay, there it is. I've got like 1,000 things open on this computer right now. I need to reduce that or get another monitor. We have just a project that I've been working on for a little while, and usually that creates a lot of windows open on this computer, and I've only got 2 monitors, which is enough to do most tasks. It's just when you get to streaming, I have multiple chats, and then I have like research window, and then I have a window where I drew a penis for some reason. Like, just a lot of mess. And then you have like a programming window, and sometimes you have CAD open. So this one needs 3 monitors. I need to figure that out at some point. When I do a monitor, I go out and I buy Simple Human stuff from eBay, because offices and hospitals and like dental offices and stuff, they close down all the time. And so all of this furniture ends up on eBay, and it's all like the premium stuff, but it's like super cheap because it's being resold. So I've gotten 4 Simple Human monitor stands. I actually have, no, 5. I have another one. It's back in storage, but it's for like a mega monitor. It's for like a big monitor. And the stream computer gets these little light LCDs, so I need a little monitor stand. I mean, I guess I could do, if I push the Dell monitor out that way, then I could do like a big meaty monitor in the middle, and that would be pretty good, because then I'd be able to put all the chat windows and stuff up on something like that. Or the OBS window where I have my actual stream monitoring going on. This is how I do it. This is how I do. I have the microphone, saxophone, microphone, sousaphone. I have the microscope on a magnetic Naga arm. So that's the way that I move that around. And when we zoom in, I actually move it way down. Then I have, it's sitting on the metal base for this soldering iron stand. I happen to have 2, and it sits on that base. It magnets to the base, and then the miniature arbor press is my counterweight. And then behind that, I have the 2 Simple Human monitor stands. One of them has basically the working monitor, which Chatterino's over in the side. And usually I'll put the OBS microphone monitors there. That's these two VST plugins that I use in order to balance the lavalier microphone that I use. The lavs that I use are Tram TA50s or TR50, I forget which one that is, and they're like $150 on eBay. They are a movie quality microphone that my friend didn't really like all that much. He's a sound guy in New York. Anyway, he sent me this thing, and I look up the price, it's like $350 new. Like, you're just sending this stuff in the mail? Production equipment prices are ridiculous. But anyway, so yeah, that monitor does all that stuff. And then this one over here does my OBS monitor, although this is a little nomadic. So when I use the face cam, I like to put the, damn it, okay, hold on. I like to put the OBS monitor all the way over here so that it looks like I'm kind of looking at the camera without making direct eye contact. All those direct eye contact filters are creepy. Those AI things that make it look like you're giving direct eye contact, they're creepy. Creepy, creepy, creepy. Anyway, now, new to the fray is the YouTube monitor over here. Look at these analytics. Look at all these viewers. 1, 0, 1, 0. Nothing. Fun. Anyway, so that's the setup, and this is why I don't have back problems, is that I'm looking up. And this is a standing desk already, right? This is like 30 inches off of the ground, and then I've got the stand, or the top shelf, and then all of the monitor stuff. So when I'm working really hard and I'm looking at something with my Mark I eyeballs, I will not notice chat. But more often than not, I'm working while looking up. I'm looking up at this monitor while I work all the way down here, because that way I am keeping an eye on my production, which is why it's ridiculous when people remind me that, you know, hey, bother, stream starts soon, is up on the screen. You know it's still there? It's like, yes, I know it's still there. It's right in my face. When does my lurker buddy show up? He's on West Coast time, so he's got to like wake up. Yeah, so anyway, all that stuff is on this computer over here. And this is a rack-mounted computer that I water-cooled for street cred. Of course, this isn't just a blank panel on the rack. This LED display, which I 3D printed, is actually a blocker because the graphics card, the EK water block on the graphics card, sticks up above the top of this rack mount computer. And I do have a glass door for this thing. I need to take everything out, move the rails forward a little bit, get the handles off of this computer, make a front panel that'll hold the buttons. I have a block from another computer that I can put on that. It's a whole thing though. This stuff takes so much time. But move that all forward and maybe organize this stuff a little better. That's the Raspberry Pi that runs both my refrigerator. It actually does. My refrigerator is running. It's not running right now. It's unplugged. But yeah, that runs my refrigerator. The brewing system is on its own Raspberry Pi, but this also runs Node-RED. Oh, that's the router, by the way. This runs Node-RED, and this is my microphone input, and that's Fartbox. Node-RED is so very important because it's actually controlling my light control. This light on the face cam would be a little bit too much, and it was for a little while. A little bit too much, and I had to always turn it away. But then I put it on a Tasmota plug, and now when I flip over to this scene, the Raspberry Pi does its magic with the Java Flow, turns off the light. Pretty cool. I want to do more stuff like that. I need to do a little bit more stuff like that in here. Of course, below that is my file server, which actually should probably be running like a Vim that's running Node-RED, because it's instead of just having the Raspberry Pi sitting there, I could take all the tasks that this thing is doing and put them on this computer. This computer is mostly bored. It's way too powerful. It's like maybe a generation or two old AMD. It's got all these cores and stuff. Yeah, it's Ryzen. I don't know which, Ryzen 3. So like, it's way too powerful. It should have been an old computer that went in there, but whatever. That's my file server. Below that, battery. The battery is very, very important and very dusty. It's very important because although we had the great expenditure to get a generator, yeah, I would love to tie that into the rest of the LEDs on that rack case, so that as I'm talking or playing music, the whole thing would be lighting up. But yeah, we're out here in the burbs. I say I'm in Philadelphia. I kind of am, but we're sort of in the burbs. Oh boy, do our power lines love branches. I think that right when we got the generator, they finished redoing and trimming back a lot of the line coverage around here, because we haven't had a power outage since, and it's been like 3 years with this generator. Spent a lot of money on it because we would get power outages all the time. And then if I did actually have a power outage while I was streaming, which has happened to me before, I would have a couple minutes until whatever the piece of Verizon that we speak to goes down, because that doesn't have a long backup. We have enough battery backups that will switch over to the generator pretty smoothly with all the electronics, but it hasn't happened. The power has not gone out. We'll see what kind of a winter we get here. What kind of a winter we get here on the East Coast, because it's already cold, and we're swinging back and forth between extremes. So maybe we'll have a pretty brutal winter. I want there to be snow coverage because we have a corgi puppy who's a year and some change old, and she has never seen heavy snow coverage. She probably won't be plussed by it at all. She probably won't care, because that's how it always happens. Like, woo, how's she gonna react to this new thing? And she's just like, I show the dog this new thing, and she's just like, there's nothing. There's no reaction at all. I don't get anything. So we'll see. I was like, oh my God, the neighbor's using a leaf blower. How's she gonna react? And she just went up to the neighbor and was like, hi, how you doing? All right, fine. I have a non-reactive dog. When she was a puppy, the breeder would go around with like big pieces of metal and like bang on them and like yard equipment and stuff. She would do like not like being disruptive to the puppies, but like making the big noise at a distance and sort of acclimating them to things. So my dog is not afraid of thunderstorms. She does not care. She just comes down here and sleeps. Like El Nino is supposed to bring a mild winter to North America, but who knows? Oh man. Well, I hope we get snow, because I want to see the corgi jumping up and down in snowbanks. Am I gonna have to drive up to like New Hampshire or something and throw the dog in the snow? 9 hours just to plop my dog down on a bank of snow for 10 minutes. My dog is afraid of a box, but not a semi truck. Yeah, that's the same thing. If I get a package and it's too big and I bring it inside, she's petrified of the thing. But she runs towards cars, which is a really bad habit. But she's so cute that when she runs towards cars, the person in the car goes, "Oh, you're the sweetest, you're so cute." My dog is going to get hit by a car if she ever runs away. Luckily, she does not have that inclination. She knows how to come back into the house when we're done walking. So she knows where the house is. She knows how to, do the last little leg of the walk and everything. I'll tell her, let's go back, and she'll just automatically go all the way back to the front door. So I hope we're good in that sense. If she ever does run away, she'll probably run after a deer and then probably come right back. Garbage bags. She will bound towards the garbage bag like it's time to play, and then stop dead scared. as you're doing the the floofing of the garbage bag. It's so weird. I don't understand the sort of disconnect between things. Then the vacuum. Leaf blowers, not a big deal. The vacuum cleaner, that gets a special bark, and it's a very stressed out bark. So my dog's weird. She's super weird. Love her to death. She hasn't been downstairs for any of the streams lately. I don't know what the deal is. She just doesn't like to be here while I'm yelling at the furniture, I guess. All right, so we're going to get the wire out of this side, but we're going to keep everything over here. This is, by the way, okay, so the LM386 is now where we're going to be going with this, because the LM386 is a much simpler audio amplifier. These two here are audio amplifiers. Well, I don't know what the TDA 2822D does. 1, 2, 3 audio amplifiers in this kit. What is this thing? Darlington transistor array. Why would you give me 2 Darlington transistor arrays? I don't need Darlingtons. Weird. Anyway, this is just a weird kit that I got off of Amazon. I have an LM386, I have a TDA 2822, and a TDA 2030. We tried the TDA 2030, and it just got super duper hot and nearly exploded. I don't know why. It was a more complicated circuit though. The LM386 is a super simple circuit. It's going to make this look a little less cool, but and I won't have this big heatsink sticking out of the skull. but it might be a better option. Let's look up the TDA2822D and see what that one is. See what that schematic looks like. Let's look at that one real quick and just see if it's an easier one. TDA2822D. Dual low power amplifier. Ah, okay. So this one's a dual. This one does 2 speed. It does, or what is the, it's like AB amplification or something. You can also do left and right speaker. Headphone. Bridge application. Well, that's interesting. The one that we're doing is the LM386, and the LM386 is a nice and easy chip. It's easy, it's safe, it's nice. It'll give us like 1 watt, which is all I really need out of this speaker. Look at that. Look at that schematic. It's nice and simple. So easy and simple. So we're going to use this. There are a couple variations on the circuit, and some of them come from the actual datasheet itself. LM386. I'm going to look up the datasheet. Oh, it finished the data sheet. This one's got the diodes built in. Oh my God. Amazing. So the power amplifier is designed for the use in low voltage consumer applications. Gain is internally set to 20, but you can add a capacitor. Sorry, it was a hiccup from eating lunch. You can add a capacitor to get up to 200 gain, which I don't think we'll need, but we'll see. 4 to 12 volts. So we're actually going to be giving it 12 volts. So this is just meant to power a speaker. And in the application note, they give you the schematic for the circuit. That's all we need to do. You know, electrical engineers have all this knowledge about how to put together systems and then always end up defaulting to exactly what is in the schematic. At least in my experience, my 10 years of experience reverse engineering things, it wasn't just IEDs, but it was reverse engineering stuff. And they just always default to the data sheet. There were only a couple times that we had to figure out what the part was based on the circuit. If you put the circuit on paper and you revise it, and you revise it, and you revise it, you eventually get something that you can sift through a bunch of data sheets in order to find. You go, what is this thing doing? Well, it's amplifying. So let's look at a bunch of amplifiers, and you'll eventually fall on something that's close enough that it has basically the same parts. It's a lot of work for a small bit of dopamine. Just a tiny little bit of dopamine in there. So if we wanted the gain to be 50, we could put a 1.2K on pin 1, 10 oof to pin 8, and we would have a huge amount of gain. So if I put basically, we'll do the 10K ohm, I mean, ours is 6K. So we're going to have a 6K to ground, but then we're going to have a resistor on VN. So the VNs that we have two 2Ks in order to sum up the left and right inputs of stereo, and then I have one singular, I think it was 6.8K, something like that, on the Eurorack level audio, because it's a greater signal. It's like plus minus possibly even 12 volts. So we had to like do basically a 5-to-1. It's like 1 kilo ohm for a singular normal audio channel going in, and in our case, just this huge. I guess we don't need a capacitor in there anymore. There's a 250 oof cap going to the speaker. That's pretty easy to do. We can get that done. So yeah, let's get the hardest part about this is going to be putting the chip and resistors onto the skull, and we'll do it in this area right here, because this is much easier to work in, and we'll get rid of all this crap. Whoever, some weirdo put all this stuff in, and it sucks. I don't know why the other circuit failed so hard. I mean, we can chalk it up to the old diodes that possibly could have caused that, but it just seems a little weird that 2 different chips would fail the same way, and one of the diodes I even replaced. Maybe there was some other element that was breaking things, but the more I looked at it, the more fine it was. There were no, like, glaring mistakes. Unless maybe just the floating circuit, something in there is shorted that I can't see. That would be another possibility. But yeah, let's get all this stuff out of here. Oh, this crap's gotta go. But the LEDs will stay, because those worked. Those are the only part of the circuit that did work. I was thinking about that. I was thinking about whether or not I want to just leave the old stuff in. But I'm going to get all this stuff out because we're going to use the same capacitor mounting locations, just for different caps. And I don't want the big thing sticking out of the side of the head. We already have like the plugs on the side and everything. I would have liked to have the input plug here, but then I'll put a decent knob on this. Put a decent knob on it. The best way, because all this stuff is sacrificial, is to use flush cutters and just flush cut it all out. Flesh cutters. I've got to get the backs of it too. It's going to be left with scars. See if I can do a little bit of unscrewing. We do a little unscrewing here. Hey, can you like mount LEDs in the holes or something? I don't know. It's a shame though, because that would have been kind of cool looking. Sorry, it was cool looking. That would have been. So many sacrifices. Let's see. I guess I'll keep those on the bar, but I'll cut that. It's still attached. Yeah, there's my ground bar. And that is just a rando connection. Oh, these are all pull-throughs. I could have done a more elegant job of this. That's where I failed. But we'll make up for it by using the LM386, and that requires very few extra components. Dang it. How'd I cut that? There's like double wires in some of them. Alright, the attempt on the speaker's funkiness has left it scarred. We'll just gloss over that with our chip. There's like, is that the end of a drill bit? Oh no. That might be the end of a drill bit. Maybe that's why this thing was failing. The drill bit shorting it out. Yeah, there's the end of a drill bit stuck in this thing. Old prison tattoos, all faded. Now it's just a little piece of wire there. I'm trying to get that out of there. Well, this could have been causing the short. I have to assume there was a short because the thing was drawing so much current. It felt like a short, but it wasn't what was heating up. I mean, we had all kinds of stuff heating up, let's be honest. This is a nasty little area right here. What in the world happened to this? Wait a minute. Now it's starting to feel like surgery. What's up, Gonad? The YouTube cops are going to kill me for saying things like Gonad. What up, Chester? How's everybody doing today? Yeah, so we're returning to Skull Island and getting this stupid thing to work with an LM386, which is a much simpler circuit. There's like a piece of wire embedded in here, and I can't do anything about it. Weird. Weird. Abbreviate to NAD. Well, I mean, I haven't gotten in trouble yet. These are just things that I think about now that I'm a famous YouTuber. All right, so still scarred. Still scarred and a little greasy looking, but whatever. Okay, and then I need my drill bits, and I need an LM386 audio amplifier, and then our circuit is dead easy. It's a very simple circuit. So the LM386s, I believe, are over here. This is such a weird kit of electronics. There's just so many weird things in it. That's the 2822. Lobotomy Thursday. I feel like I've had a lobotomy. LM386. So that was a cheap doctor's visit, but I don't know how legitimate that doctor was. Took a file to my brain. So what about these? These look like they're perfectly spaced out to be chip pulls. And we could do this right there. Okay. So I just need a couple more. I need one in the middle of those. Well, that's actually, the two over here are a little bit spacious. Hold on, let's, and I can, the holes that are already there, these guys, I could always just put wire in there just to make them look like they're doing something. We could use it to host components too. Like, those are spaced out a little bit. They could be used for the chip. Those are perfect. If I do it up here, I'd be drilling more holes, but it wouldn't be too bad. And where does that put us? That puts us right, you guys can't even see it. I don't want to do it on the dead top of the head. I want it to be offset a little bit because it's funky that way. So if I do it here, and I use these two to locate it, I can use a piece of perf board to aim my holes. I have a piece of perf board? Yeah, right here. And then a pin header can locate me. I don't want to drill that many holes. Every time I take out that drill bit, it's risking the drill bit. The drill bit is nearly dying every single time. But that's not a bad idea. Boy, these are old. Okay, that'll do. This is a little close to the top of the skull, isn't it? I do want it to be off to the side a little bit. If I did it here, it would probably be difficult to work on. Those are too far away anyway. Yeah, I guess we're stuck here. So it'll just go right here towards the top of the skull. I mean, I can use these for some components, and then I can use these for components too. So everything needs to be flat because this thing will tend to fall. It tends to fall off of tables and stuff, so I don't want to have stuff sticking high up out of it. And we can cover these by putting resistors in there, or LEDs in there. I can figure out how that works. I don't want to put a full op amp on this though. So I need to look at what, like, if I can just directly connect it or something. How many rows of holes do we put in between? That's 2. Okay, so let's get a drill bit. We're back doing this stuff again, huh? Didn't mean for this to become my permanent stream project, but if the LM386 works the way it does, there's very little surrounding componentry, and although it's not going to get to the full capabilities of this 4-ohm speaker, it will use it pretty nicely, and it'll be able to give it a little bit of volume. The whole purpose of this Skull speaker is just to be a monitor. I just need to hear what the synthesizer is doing. What the dog doing? I gotta be careful not to, like, suddenly drop this thing, because it'll break the drill bit with wanton abandon. Let's just, like, use this to mark it. Maybe that'll be better. Of course, this is a flat projection onto a curved surface. You want wonton soup? It's a cool day. It's a good day for wonton soup. Today is a good day for wonton soup. Kid named Wonton Soup. They're a little uneven as a result of my incredible measuring technique. Probably should have just, like, put dots down or something. I could have measured. I could have used rulers, but whatever. Yeah, these miniature drill bits versus this plastic. It's nice that the plastic is easy to drill through, but if I tilt wrong, these things just die. So now I'm out one of my miniature drill bits. I may need to get a whole new kit. It might be more economically feasible for me to buy an entire kit of drill bits instead of an individual drill bit. Oh yeah, these are way uneven. Whatever. These look terrible. PAM 8403? What is that? There are likely better tools to be doing this with, but I just want to get it done. I just want to get it done. Okay. Most of the connections to this thing are to ground. Pin 4 goes to ground, pin 2 goes to ground. So I'm going to roll the pins a little flatter. Rolling technique. Oh, little amp board. Yeah, but that's cheating. We should be able to build a circuit like this successfully. Shouldn't need to faff about as we have. Chester's joke about propaganda was very good, and I did need the context for it, because I forgot about that joke. It's a British person having a good look at something. Having a propaganda. Ah! Damn it. Oh, I almost bent the pins there. These are all in weird spots, these holes. Maybe I'll put another hole right there. Yeah, let me put another hole in it. It's usually pretty organic, the way I come up with the projects for stream. The synthesizer stuff, of course, was on the goading of Julian, my buddy who does music production, half of Radioactive Sandwich and Zelikovich Music. He's been after me. It could also be it could be the correct goose, proper gander. I didn't think about that. There we go. Julian was on me for like 20 years about to get me to do a synthesizer project, and I never did. So he linked, I think he told me, because I was getting him in here to do like little projects, like fixing his stuff. He's always very appreciative of that, and he knows how to do, like, you know, filling the dead air. He knows how to do that. He naturally does it, and he also has worked in radio before. So he's like a perfect person to get in here for project stuff. And also he fills the stream with rights-free music. Other stuff has come about as just like a little idea. Like, I had Three Mares sent me this dollar store fart noise maker, and I said, well, what if chat could control that? Because a lot of the kick for this stream is like, what can I build that chat can control, but I need to make it properly, like, oh bother complicated, right? I need to do that. So I made the fart box as a result of having a bunch of stuff to take apart and having components of things, and then the internet loves an ESP8266 project. So we got that, and then we got code in there, and then coders love nothing more than to see how shittily I code, because then they come in here and they correct me, and I get good code out of that. So I had LebTV Live, a friend of the show since the very first stream. LebTV Live came in and was like, here's code, and I renamed all the variables to tell you exactly what they're doing. So that I thought it was just him being very German, but the variables were like, this is the variable that takes this number and puts it into, they were like a sentence per variable. But we got all of that running on an ESP8266, and it gets all the way into the Twitch API. And the thing programmers really, really love is when you're struggling to do something, because they can come in there and go, actually, bother, this is how you do it. You need to do this exactly here, and then this and that and the other thing. And so that is like the bumpers in this game of bumper pool projects that I do. It helped me out a whole hell of a lot, especially with Node-RED. Node-RED, I have no idea how it works until somebody explains to me what Node-RED does, and then I'm like, I'm starting to see the universe, and then as soon as I'm done, I forget all of it. That's been sort of like a big crutch for the stream. I would have given up on a lot of projects. Part of streaming is that you have to get it done. You have to get it done. You have to get the project done, right? ChatGPT. That's right. Yeah, we were talking about that recently. Is that ChatGPT is possibly the greatest study buddy known to man, because it's not judgmental when you're as stupid as we are, and it will always try to filter things, because you gotta keep in mind, these AIs are chat AIs. They're designed to communicate with people. That's why this whole I'm a prompt engineer thing is fucking stupid. It's not designed. I mean, there are ones that are designed to make art, and those you do need complicated prompts. They call everything an engineer nowadays. Like, what was your capstone project, Mr. Prompt Engineer? Anyway, but ChatGPT is designed to chat, and the important part about that is that it will chat with you, and it will get you to help you to understand things. So if you are studying and you don't have a study group, it's really useful to just get into a conversation about the subject with, and it will try to bring you into a level of understanding. That's where it shines. That's where it's really, really good. All right, so I'm staring at this thing. I don't even know if it's Java or JavaScript. Ooh, don't say that out loud. Don't say that out loud. The programmers will tear you apart for that one. They tore me a new one for that one too. I still don't know. Are we building this one or the other one? They're mostly the same. It's COBOL. Oh, oh, where was I? I just whited out for a minute there. I just heard ee. I think we're building this one because we're going to start with 20 gain, and if we really need to, we can then do the resistor and the capacitor. Let me get liquid, otherwise I'm going to desiccate during this entire stream because my glucose level sucks right now. Oh, dear God. Well, hopefully it's on a swing down. You can see all the little micro boluses that it's giving me here. Doot, 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 doot. It's just that my stomach isn't draining, so it's going to stay. It's not really going to go anywhere. I need to change lunch. I need to stop eating meals and start eating tiny snacks periodically. I think that's what I need to start doing.
Hyperglycemia makes you thirsty.
I don't mean the internet style thirsty. I mean, well, actually, it does a little bit. Yeah, there's a component of that. I've learned to like PowerShell for sysadmin. Apparently, it's pretty powerful to have a virtual machine where, because like my only experience with this is with the microcontrollers for the modular synthesizers, but Mutable Instruments, Amelia, has just this whole thing. You just spool up your own little Linux machine, and then you use that to do all the compiling. So there's nothing else to get in the way. You don't have like a printer that gets in the way of your programming a microcontroller. Yeah, look at how few extra components we need on this thing. That's pretty cool. All right, so audio in, coming in through this thing. And we've got our power switch there too. Where's our power going into? I think it's 1 and 7. Let's check. Let's check. Yeah. Bypass. Ground, V out, VS. So between pins 4 and 6. Validation engineer? Wait, I need a validation engineer? You are important. The math here says you're a good guy. Validation engineer. I've calculated exactly how worthwhile you are for this company. You did a great job on this report. Their positive signal is, oh, there's text there. There's text there. What's that text? Control C. What is that text? Oh God. VS! The VS label is there. It's right there. That's VS. It's just in clear. What the heck? Come on, guys. I mean, consensually. Huh. So 6 and 4 are power and ground. How are we going to do this circuit? I don't have a lot of lead on the other side of this, so I could drill the wires to go up. Actually, I don't know. This drill hole size might not work with that, and I could do the circuit flat on this. Let's see, the resistor I need is coming from the output, so it's in parallel with the speaker. Ground, 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 and potentiometer. There's nothing to the circuit. I need a 250 UF and a half a UF. It's a 50 nanofarad. Oh my God, this is so simple. All right, this is an LM386, by the way, for all of those of you that are playing at home. So, the resistors, I know I've got over there. It's just the capacitors. Those are up here. Yeah, as soon as I was like, man, you know, this TDA 2030 really didn't work out. And so I looked up circuits for the LM386, and I was like, it can't be this simple. That's not possible. But it is. The LM386, not a lot of power, but it can drive this speaker just fine. Isn't that crazy? Just a couple little support capacitors. We need a 250 microfarad. The bigger the better, because it looks cool. This one's 220. That'll get there. That'll get us there. And it's one of these. This is one of these gold ones, so it's like audio or something. I don't know. Aren't the gold ones like better than the regular ones? That's what I hear. I dream that Cranktown City will find my YouTube stream, and finally I'll get respect. Is it Cranktown City or Cranktown? I forget, but that guy's awesome. He's like, I'm gonna make a CO2 laser, and then he does, but it's out of like garbage. It's amazing. It's a mechanical guy doing electrical stuff, and I'm there for it. 220, I think, is as close as we're gonna get. That just means it'll filter out slightly less super high frequency stuff. Or more. I don't know which way that goes. 220. Yeah, I think 220 is all we're really going to find here. It'd be weird if there was a 250. 220. We use the one we found. All right, 0.5 microfarads. What does that mean? Capacitors do this big jump where you have microfarad, nanofarad, and picofarad, and they're just a couple decades apart. But if I have a 0.05 microfarad capacitor, we can just go to that on this chart. You know, it's a little weird that I'm doing it like this, but 0.056. So that's the closest we're going to get. That's the normal value. 0.05 is a weird one, but 56 nanofarads or 56,000 picofarads, and then the capacitor code that would be written on the outside is 563. So 56 with 3 zeros. So we're looking for 56. I'm not going to have that in these. That's going to be like a chip capacitor. I have 220.1, which is close to 56. Not incredibly close, but it is close. Well, it's double. Why that value? Let's see what other people are using, because I'm sure there are other circuits that are similar to this that have different values on there. So actually, well, right here there's one. Yeah, see, 1,000 micro and 100 nano. I don't know why they have that resistor in there then. I'm not even going to put that resistor in there. And then we don't even need to worry about bypass. So on pin 8, I'm just going to do... What is their circuit for? I'm still going to do 250, and then we'll do... well, I don't think I have 100 nano. Wait, 100 nanofarad is 0.1, right? Yeah, I do have. I have a better looking one, too. I have a cool looking one. I have this blue thing. $100 nanofarad. I don't know. These were just, I thought they were a different value when I bought them, so I need to use them up. And it's kind of weird looking, right? So we'll put that in. Okay, that's all the components, other than a 10 kilo ohm resistor to ground. So it's this, the chip, and where did the resistors that I just organized go? And this. And we're golden. Damn, that's simple. It's so simple. So where's 10K? Let's see, that's 100. This one is unlabeled. $1K. Okay, 1K. Let's get 10K. $10K. So few parts. So now I got to figure out what I'm wiring this up with, and it's probably going to be resistor leads so that I can do another circuit like the one I did before. How can I make it better? How can I make it cleaner? Cleaner is really the word here. So I can either build it on the surface and pop my wires up, maybe from there, to go to ground. Maybe it should go on the surface, because that way, what pin is that? Pin 5? So it's this pin here would be the output. And then I could pop this under pretty much anywhere. Pin 4, what is that doing? That's going to ground. Well, that's good, because that's where a lot of these things are going. Oh no, pin 3 is the input. 1, 2, 3 right here. So I can put a resistor in there, and then that one goes to ground. Pin 2 goes to ground. Everything goes to ground. Let's see here. How do I want to put this together? I mean, I'm just kind of thinking about whether or not I want to do a surface circuit, which would be a lot easier to do, or if I want to bend leads down here. Bending leads down here, I don't have really anywhere to go in under the chip, because the chip's leads are only so long. But I guess if I do it all on the surface, that means it's going to pop off. So I might as well put the 10K in. What else? Pin 1 doesn't do anything yet. It's 1 and 8 are that feedback loop. So I can install components across there if I want to increase the gain significantly. We're going to start with 20 gain and just see if that works. Really is between pin 3 and 2. So if I go this way, I can then bend that over and back underneath the whole thing. Unfortunately, my circuit building skills are not going to be able to be shown off very prominently. Although you saw what type of disaster this thing was before. But okay, so two leads here. And we're going into pin 3, which is also where I need to put the audio after the potentiometer. If I turn this around the other way, no, but then I have the 2 components that go in there. Yeah, we'll leave the scarred area scarred. There. Like over here. It's getting a little close. It's like 3 components. This is ridiculous. Okay, there's our resistor into pin 3. So I'm going to bend this down and get that to pin 3. And that's also where the audio signal comes in. And then the other end of the resistor goes to ground, which is pin 2. And pin 4. So I could actually bend this to pin 4 and then do a little loop to pin 2. So this one gets cut flush to that pin. It's hard to see. I can't, unfortunately. Usually I'm pretty good with the microscope, but that's when we're building something that's not the shape of a skull. Having it be the shape of the skull means it's a little harder for me to maneuver things around. That pin right there. Let me get that soldered. How am I going to prop this up? I need like a giant vise to hold this thing. I guess I could use the vise that we were using before, right? Where did it go? I've cleaned it up. Oh, it's like way over there. All right, so I just need to hold this just right. This is stupid. I can't wait to be finished this. I'm so sick of it. No, I'm not that sick of it. All right, let's see. Let's see, that one goes, I need this one to like stay there. Oh, and the chip fell out. Part of the reason that I'm doing it this way is so that the chip stays in. Once I solder it, it'll be held in. It's not like I can solder it to the plastic after all. What does pin 7 do? Pin 7 goes to a, oh, we still need 100 microfarad. Well, let me get that real quick. Or is that this one? No, that one's 47. This one is 100, but it doesn't have the leads anymore. And it also goes to ground. Everything goes to ground in this thing. That one's the ground pin, but then this one's the one that goes to that pin right there. So we need to get a different 100 up. Plus, I don't trust this one because it got super duper hot. I don't trust these components anymore. I need a nice big 100 oof. That wasn't easy to find. I remember that one being kind of hard to find. 47. Oh, well, there's one. That solves that. That's 1,000 oof. If I could find one of the silver, the gold ones, rather. 680. I don't know if I have that. I don't know if I have the super duper capacitors in 100 oof flavor. Yeah, 470. I don't know how vital this one is, but oh well. So that goes into pin 7. This is according to the instructables. I've got 2 different circuits, so. And then which pin is ground? If I do it this way, I can get to a ground pin and pin 7. Of course, I got to cut away some of the plastic, it looks like, in order to get there smoothly. So let's just do a little more snipping right here. Looks like my flush cutters do not get any more flush than that. All right, so I need to get those wires soldered. Actually, while I'm here, I can move this one up a little. No. Push it in. Should make a nice little interface there. So 1, 2, 3, pin 3 on that one, good. And 4, I'm going to loop around to the pin. There's a lot of grounds, so it's going to be kind of a big mess of ground wires. And I actually need to start up the soldering iron now. Of course, I gotta move the light too. Move that up and over. Yes, my entire YouTube view. I don't know how YouTube spools up. I think I need to start using categories. I don't know the first thing about it. At least I'm getting the content on there. Right now it looks like an unestablished channel, so we'll eventually get there, and then I think all the appeal will be there. Okay, so use the tweezers, maybe the pin tool. I'm going to bend that up around that pin. I don't even think I can get to that pin from here. Oh, I didn't even solder that. I just put solder on it. Oh, jeez. Doing this from a distance is also not great. Okay, there's that. That will go there, and then I'll do a line flat across to go to grounds. So those two are in contact with each other. I should be able to solder it. Of course, I'm soldering into plastic. That's the problem. You put a finger behind that so that it doesn't slide in. Oh, it's getting a little stinky. A little bit of plastic smell. All right, that's definitely soldered. I think. Can I pull the chip out? No, the chip is stuck. That means it's soldered. Okay, good. Good. Because I'm going to be soldering a wire from here to there. And this was in the wrong direction. Let's get the pin off of that and make sure. Actually, I think we need all 3 of the lines from this. Because we'll do... Or no, it's not that... So, okay, wait. That's the 10 kilo ohm to ground. So our audio signal's coming in, and we can just use whichever 2 pins are going to do a small resistance when it's turned on and a large resistance when it's flipped all the way. Or sorry, a small resistance when it's flipped all the way to the end of travel. Jeez. End of travel here. Check out which one reads ohms. We'll just use 2 pins of this. I won't do the loop thing. Just in case I need to reconfigure it, because I'll get it wrong. We are at full volume, so we need the smaller resistance. 9K. 1.5. How come when we did it the other way, it wasn't working? as soon as I flipped it on, it was at full power. That's not, maybe because that's the way the op-amp circuit worked. So the ones that I was using were the correct ones. I can just go from the center pin to that little juncture. And I'll do that later because right now it'll get in the way. So I have a lot of things to hook up to ground right now. And then we also need another capacitor. So we have a 100 microfarad between pin 7 and ground. So here's a 100 microfarad, and it has a ground pin. Since it's going across these two, I will make, well, what other pin? It goes to pin 7, which is right here. So I will do this orientation, like that. This is the thing that's going to break off when this thing falls off of a table. That's going to this pin, which is fairly hard to get to. That's the only thing it goes to. Weird. This is why I have the whole debate about doing the circuit on top, is because all of these pins to the amplifier chip are very, very small indeed. But there's only a handful of them, so that's nice. And then 8-0, 6 power. Oh, that's tough to get to. 2 and 4 are ground, the only other grounds. There's nothing on this side that gets ground. Oh, great. So I might as well go down and over to this pin. Instead of going up to here, I'll have to get a little piece of wire in order to bridge that one right there. You guys can't quite see what I'm talking about, sorry. You can get closer and look at this. So these barely stick through. So I kind of bent this around to try to get it to go through there. But where is that pin 7? It's like all the way up here. There's a seam that I got rid of right on top of the chip, and that's not really helping me in terms of the pin lead length. Not helping me at all. I could take the chip out and put the pin... oh, no, I can't take the chip out anymore because I soldered. Well, I could always desolder this one, and then I could stick the pins up through and then sink this thing into the same holes. How much room do I have? Like, all the room in the world. That's probably the way to do it, then. So, let me get rid of the solder on this one. I need another 10 kilo ohm resistor. Oh my god. Oh, great. That's just made a big mess of the plastic right there. That one's not coming up without a fight. Uh-oh. Might need another one of the chips. My insistence on doing this in a weird way is what's become my enemy. There we go. A little bit of a struggle, but wasn't too bad. So I'm going to get another 100 kilo ohm resistor, and I'm basically going to stick the wire up through, which actually means I need another 100. Oof. Because I need that extra wire. There's one. Apparently they're not as rare as I thought. Like that, and then what I'm going to do is go to pin 7 over here and just shove this thing through and pull it taut. Where is that pin? There it is. It has 2 hole locations for this pin. I'm going for this one. And then I need big pliers in order to pull on this lead. This way I can just make sure that they're soldered by soldering them up above. Yep. Okay, so the question is this going to fit through with the chip? And the answer may surprise you. It's yes. Okay, it's yes. It does fit through. I need to clean up the one pin on this. Okay. So then we do the 100 kilo ohm. We get a new one. It's not like I don't have them. Sorry, the 10 kilo ohm. 10 kilo ohm. 10K to ground right here. And our ground pin is also pin 2. So I will go from here to here. Actually, I just bend them at the resistor. That's kind of the width that we did. Bend them at the resistor. This is through-hole stuff. You know, surface mount is a little bit more popular, at least with me, because it looks more technical than me just bending leads all the time. All right, and then I'm going to loop this around and go into pin 3. 1, 2, 3. There's a huge blob right next to it. I need to use the knife to clean that up. The soldering iron poked directly into it and made it kind of difficult to see where the hole is. And you can see it perfectly fine from here. That one right there, second from the bottom. I need to use light in order to see it. Those aren't tweezers, it's a knife. I'm going to hold it up to the light where I can actually see pin 3. I'm treating these solid leads like I would wire. It's kind of weird. This one goes to pin 2. It's also the beginnings of my ground plane. I'll just bend that to the side so it doesn't contact. It does not contact. Weird. Why am I talking weird? I could use a sacrificial lead to try to go from that pin, if there were enough room. There is. I'll cut that resistor off. But I can go from there to there. But why was my volume on the other one backwards? You know, it's doing okay today. We decided I use the royal we because that way it sounds like other people are making these decisions and not just me. We're using an LM386, and the LM386 is a dead simple circuit. Look at the number of components that I need on this. A 10 kilo ohm resistor, a 100 microfarad capacitor, a 100 nanofarad capacitor, 1,000 microfarad capacitor, and, you know, maybe a 100 microfarad just to decouple. Just to be nice, but I don't really need that. So there's way fewer components required on this. I'm just making all these little decisions about how things should go together. I don't know what happened to the other one. I don't know why that one doesn't work. It has every reason to work. Shouldn't have cut the lead off of that thing. Huh. What I'm doing here is I'm actually using the holes, the oversized nature of the holes, to get all my connections to the IC. So I'm running the wires through the holes of the IC and making my circuit connections that way. That's barely, ugh. Okay, come on. Come on, Shotter. Oh, come on. That was definitely connected. It just was messing with me. There we go. Ah, damn it. Okay, never mind. That didn't work. Let me get another lead. Maybe it's longer. I'm a sacrificial resistor. Nope, it's the exact same length, and also still difficult to solder. Curses, that would have been so elegant. Okay, I could just use wire to do this. I can just use wire to do that. One thing that I do need is ground. So pins 2 and 4 need to be connected together as a ground. So 1, pin 2. Wait a minute. Yeah, pin 2 and pin 4. So skipping pin 3. So if I go down through here, I don't know if I can manage to do 2 wires. Well, if I need to, I guess I can apply a little bit of heat, and then they'll melt off the melt the plastic away and allow the pin lead to go through. Okay, I need this to skip 1 and then bend down, so I can actually build that here. I can do this, bend these down, and then take that and bend it over, just like that. There's my pin skip. Easy enough to see on 1080p. It's very visible right now because I keep moving it around on my fingers. And here, it looks like this. So just a little swoop. And I'm going to put that in so I can avoid shorting to that pin. It's like impossible to see anything in this project, but this is like I'm mad at this project, so I need to get this done. I need to get this done for me. That's why we're still working on it. Temptation exists to just throw this thing out and never talk about it again. What happened to the skull speaker? Oh, what skull speaker? I don't know what you're talking about. Could be anything. Must have been the wind. Just gonna make sure that this thing can plug in. It blew up. It exploded. So many lives lost that day. Can't even see what I'm doing. And tweezers aren't holding on to this as well as I think they could. And this needs to be a little bit more spaced out. So I'm going to widen it a little. Yep. That. That should do. That should do. I don't know. These are like when I'm building like a perforated prototyping board. This stuff is so easy. I'm trying to do it in an awkward shaped thing. And that's what really makes it so difficult. Of course, the tweezers are also not gripping. You guys know, a good artisan always blames their tools. That's how it works. And you guys got to remember that you are the softest thing in the shop. You're the only thing that can heal. You know, your tools are not going to heal. So absolutely get yourself between the workpiece and the table and the tooling, because you know you can heal. You're gonna get that finger back eventually. But the wood's done growing. It's done. You took it during its prime. It's no longer going to heal. All right, that'll go there, and hopefully avoid pin 8. Yeah, it looks like it's avoiding pin 8. gonna be kind of difficult. Maybe I can do just a little upwards on this. Bent it too early, so it's not quite long enough. It's got to go diagonally. Well, I mean, I guess if it just goes over pin 8 and doesn't contact it, it'll be okay. Yeah, we could get away with that. I don't know what happens when you ground pin 8 on this circuit, but that's the way that needs to work. Emergency marshmallow. I'm not the softest thing. I have this marshmallow right here. Cut towards your chum, not your thumb. I got this just for people like you dickhead. That's not soldering at all. Oh, great. I just melted a bunch of plastic onto my iron tip. Hate that smell, man. Smells like progress, but you don't have to like it. There we go. Okay. That's that ground. What else is grounded on that side of the chip? Pins 5, 6, 7, and 8. 5 is output. Wait a minute. Oh yeah, pin 5 is output. So that'd be this one all the way up here. So we need to make a little room for output there. 5, 6 goes to power. Did I miss pin 7? 5, 1, 2, 3, 4, 5, 6. No, that's pin 7. Pin 7 just gets 100 microfarad. Hey, may just... They were co-streaming to YouTube, but nobody would know. So this is our output pin right here. And that goes to 1,000 UF and then 100 NUF. And this is a 100 UF. But we need 100 nanofarad. That's going to be this blue guy over here. To ground. I'm kind of sorting out all the grounds right now. We're got a cool skull speaker that we've been working on, and it's been rather annoying. Just getting all the circuit elements wired up. But the LM386 is going to be our savior in this case, because the LM386 is so simple. Simple. Zoom, 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 zoom. So I'm going to put that right next to this, and it'll just be 2 holes right here. And there's also a 1,000 UF. So we'll have a bunch of caps over here just kind of hanging out and protecting each other. 6 feet apart. It's been quiet. The channel's been dying a little bit. We've been just kind of dying a little bit here. We do a little bit of dying. Actually, if I can move it away a little bit, I could put the hole right there and reuse this one. So I'll do that. Oh yeah, I think we experienced this last year, and it also got me all concerned. But yeah, everybody's busy doing stuff. It's just, I was blessed with a November birthday, so it's super close to Halloween, and everybody is busy. So it's like if I had a stream, I wish my birthday was either during sweeps month, which was last month, I think, or during bonus month when everybody's getting their tax money back. If I had a birthday then, I'd be a millionaire. Oh, I see. Wait a minute. Our pin avoidance has made it so that 4, 5 is right in the way of this thing. So I've got to move that. What's pin 4 doing? Pin 4 goes to ground. So actually, this lead is, no wait, pin 4 is on the other side. Pin 5 is what we need, and this one gets in the way. So what I can do is I can, I guess, lift it up. What is pin 6? Oh, pin 6 is even VCC. So yeah, I probably should have gone up and over with that instead of going, yeah, going up and over would have been a better idea. Hold on, let's undo this then. Trying to get work done. As if you could ever get any work done, please. Don't even come at me like that. You doing work. Ha! Okay, I'm clipping this and we're getting another 100. Actually, I probably shouldn't clip it. I probably shouldn't because I'm running out of hundreds and I keep redoing this part of the circuit. It has to be perfect. It has to be perfect or I'm worthless. Flip it a cap. So this one goes to ground. So I guess, but then this pin here goes to ground too. So I'm going to go up and over with this one. And then this one's going to go to pin, none of them. 7, 8. This one needs to go to pin 7. But now it's avoiding the bottom of the chip, which is where power is going to be coming in, as well as the output's going to be going out. Output out, power in. Well, by the time we get to the more popular months of people watching Twitch, I'll have that YouTube channel looking like it's a real thing. December's kind of a weird time. I do have a lot of family to see. I would love to just stream during December. Those are always my favorite streams, are the holiday streams. I'm starting to learn about a physics topic that is very dense and will likely get tired of studying, but I can't waste the motivation I currently have. That is completely understandable. I vibe with that. I'm on that wavelength. So pin 8 doesn't do anything because it goes 1, 2, 3, 4, 5, 6, 7, 8. Pin 8's all the way up here. And pin 8 doesn't do anything. Pin 1 and pin 8 that are a capacitor thing. And then this is our ground. Or no, this is our positive. Yeah, and this is our ground. I'm going to bend this up a little bit and get it way out of the way. And then this 0.1 goes to the junction of the 1000 UF. So I need to get the 1000 microfarad in here. Let's find it. This has big leads, so I'm not sure whether or not I can share leads on that. Did I just see something flash by? I miss those notifications because I have them pretty subtle, so I need to look at Streamlabs a little bit more. Again, I need to have a monitor that's just dedicated to all of the stream feed stuff. Nope, we just had the Wayne Johnson gift sub when I was being pathetic earlier. Where's my OBS window? There it is. Okay, we're back. Sorry. I have to pause to look around every now and then, or else I am liable to hit my head on something. I think this might be a little excessive. Might be a little excessive. I mean, we were just going to use that golden one. We might as well just use that one. I don't know why that was inappropriate. Where did it go? I think I clipped it too much and it wasn't going to work again, right? Oh, there it is. Yeah, he is. Yeah, let's use 220F instead of 1000. Or I could use this one. Oh, this one's 1000. Wait a minute, we'll just use 1000. We'll follow the schematic. Dun, da, da. I have a monitor for Stream Mangler so I can see the events in chat. Yeah, see, I was going over this earlier. I do 2 monitors. I still have one of the Simple Human monitor stands. I have a big one. So I need to get a big monitor and I can put that in the center and then that can host my OBS and stuff. But when I'm talking to you guys, it's labeled chat. When I'm talking to you guys, I like to drag this window over to the other monitor so that I can see myself because I'm very vain now, so I can make sure that my shot's okay. So my shot looks okay while I'm talking to you guys. Because otherwise I'll be on the face cam, but looking at a different monitor. And so that's what this looks. This is me looking at myself and the chat on screen while talking to you. And this isn't how you talk to people. You can talk to people like this though, and then I'm not making eye contact. It's eye contact's uncomfortable. I don't know. So instead of looking directly at chat, I look a little bit off of chat, and it sort of looks like I'm looking at this window. So when I'm addressing you guys, it looks like I'm addressing you guys. Yeah. Streaming is weird. I'm just sitting here yelling at the furniture. I'm sitting here yelling at the computer monitors in front of me. It's no wonder the dog no longer comes downstairs. I wish she did, though. She hasn't been on YouTube ever. I don't know, I tried to explain it to her. She just licked my face. So this one is also ground. Of course, in the span of my talking to you guys, I lose all my tools. There we go. I see this is a thicker lead, so it doesn't like to bend. Always use a pin tool for that. Of course, I bend it in the wrong place. That'll connect like this. Let me get that soldered so that this stuff kind of stays in place. And then I need a lead to go down here. Maybe that'll be this one. But I got to get the other stuff wired up first, so this should be very simple. It's just becoming just a little bit cursed. I'm going to try to keep it nice and organized so it doesn't become totally cursed. What would a skeleton speaker be without a curse? That looks all right. Okay, I'm just going to take a piece of a lead and do that connection. So I got a couple scraps sitting around here. I'll use this one. That's why you always keep the scraps. Never ever throw anything away. It might become useful someday. Don't ever organize or clean up or throw anything away. Never. Not even a little. No, man, that's the ABCs, though. Always be cleaning. Oh, great, that's sunk into the plastic. I didn't need that. I don't need that in my life. I need to bring this thing out of the plastic. I probably should have put Kapton tape down before building the circuit. That way it wouldn't sink in as I'm putting it together. I like to work very flat with my electronics, so it unfortunately is causing everything to sink. I'm gonna tin this, pre-tin it so that it solders quickly. Famous last words. Dad? Yeah. Don't become a hoarder. Nothing more disgusting. Minimize and organize. Always be cleaning. ABC. I am unfortunately streaming to you from the middle of a pile of garbage. I just can't. I keep trying to organize. Shop is not a clean place, but the advent of a dog means that there's now dog hair everywhere. So I got a vacuum in here. And I've been trying to lift things up off the ground, god damn it, so that I can actually get a vacuum in and vacuum painlessly without running into a bunch of stuff. Going to be a lot of little ticking noises, though, from the vacuum, that's for sure. The screws of Project's ghosts. These go together so much differently when you do it on a circuit board versus when you do it on this stuff. Like, that was going to be a nice clean junction, but it's like completely cursed. Keeps sinking into the plastic is what's going on. I should put down Captain Tape in order to keep myself from sinking in. The junk is really useful. Let's look. I know the stuff is needed to make stuff, but when you get overstuffed in your crust, holding on to like kids' toys because they might have cool audio stuff. All right, yeah, that's a good juncture right there. Lift that up a little bit. This is my ground plane, so it pretty much goes everywhere. Everything in this circuit is ground, ground, ground. So if you are building it on like a perf board, having one of those perf boards with like one side being ground would be pretty useful. A dragon on a pile of gold. Not as eloquent. I find hoarders to be somewhat fascinating because if they just went through their stuff and threw out the literal garbage, they wouldn't be in that situation. But they're literally holding on to actual garbage. And I know there's a depression element to it too. There are whole accounts where they go through and they clean up hoarders' houses. Crazy. Okay, so we need one more capacitor. The 0.1 goes to the junction of the output capacitor and the amplifier. So I'm saving this to bend down onto that line. And then that output is going to come from pin 5. 1, 2, 3, 4, 5. It's this one all the way down here. And I'll just have a capacitor down here, and then this thing will just go onto that same line. So maybe I'll do it diagonally. It's not going to look great, but nobody's going to see it. It'll be inside. Our shame will be hidden from all of the outsiders. It's going to be this chunky dunky monkey here, and then I'll go just right there. I just got to give it a little bit of breathing room. I could go all the way down there and then put the other lead up here. That's a little far away though. Oh wait, no it's not. Hold on. Yeah, if that other lead just goes right there, it's actually a pretty good spot. At least this material is nice and soft. Although if I did my idea of laying down copper and then cutting it away, that would be really cool. Because I think there are one layer editions of this circuit. I'd rather do surface mount parts though. So the positive lead is going to go to pin 5, and then the other one goes there. And that's a pretty big wire, but... And that's our speaker output. That's where our speaker's going to hook up. Yeah, this one's much more solid of a lead than its buddies. Pin 6. Oh yeah, 6 goes to power. So we got to get pin 6 out of here without running into anything. Which actually, that's not going to happen. Huh, interesting. Our power connection is going to be difficult to figure out. Okay, there's that one. And then this lead will just go into that lead. I'll bend it out this way. And then I guess I'll solder it and then cut it. Yeah, doesn't quite work. The people in this neighborhood are so weird. I think a lot of them go to Florida. There's something about Florida and Pennsylvania. They're like connected somehow. But with a lot of people leaving for Florida, I look at like other trash bins on trash day. We have like a bunch of trash bins. Everybody else is like nothing. They have like no trash bins. They don't have any trash. I don't get it. Maybe I'm extremely wasteful. I think it's also people without families too in this neighborhood. All right, so there's that connection. And then this is our output to the speaker. Mr. Speaker. Which I could either run a wire up to the top and have a wire go to the top, or I could do it internally, which is what we did before. Probably what we'll do here. Let's see here. So that's pin 2 and 4. That's a really ugly connection there. Just clean that up a little bit. It's still disgusting, but let's see. I got a connection here where, what did I do? What did I, wait a minute. Oh yeah, that's the resistor and then the ground. Resistor there. Was that supposed to be, yeah, 4, 3, 2. The resistor goes to ground. And then this one is actually the one where we go to our input. Oh, okay. Wait a minute. I was going to wire the input to ground if I had done that before. So yeah, this one right here, right next to the action, is what we need to go to the, what pin does that go to? Pin 2? Oh, no, that's wrong. Pin 3 is the 1, 2, 3 is the output. And then pin 4 is supposed to be ground. Oh, I did my ground bar wrong. Yep, that would have done it. That would have done in the whole circuit. Well, I caught it early. So it's, oh no, that's pin 1, 2, 3, 4. 1, 2, 3, 4. Okay, no, we didn't do it wrong. That one goes to pin 1, 2, 3. My brain hurts. 2 and 4. 1, 2, 3. Okay, so yeah, I can wire this one all the way over here to here. That can be nice and clean. You know, you try to not make it cursed. Do your best. Your best isn't good enough, and it becomes cursed. Like barely going to get there. I mean, if I do it across the 2 leads, but we did that last time and that made it have audio at maximum volume right after the switch, which is a little weird. And then it went down from there. From here to here, there's very low ohms when I turn it all the way up. When I turn it all the way down, there's high ohms. So this has to work. I can't fathom that this would go the other way around. Clearly, we would get more gain with less resistance. It has to be. That has to be the way it works. Oh, carefully. Oh, come on. It was still molten. Because there's so much solder on the lead, when I heat it up, it holds on to all that heat. You have to wait a bunch of time for it to cool down. There we go. All right. Here's that. Then I need to get rid of the resistor on the end and then solder those together. Hopefully without melting everything in the process. I think that did it. It's going to look a little weird with the solder on the top there. I can always draw it down. Okay. Oh, that's okay. A little bit melty. Those are going to be the IC soldering is going to be the weird part. All right, let's see. So there's the speaker output. Power input is going to be a difficult one to do. It might just be a bent lead that just kind of sits there and a wire going directly to it. Because there's only one power hookup, although there's a 100 microfarad capacitor on it. So if I want, I guess I can add another 100 UF. That goes to the speaker there. I'll just bend that sideways so that this stays on. There's a bunch of big capacitors on this, huh? I guess I could put a cap like here. Let's find 100 microfarad. 100 microfarad is a lot. I guess this thing has spiky draws as it's an amplifier. You do a 220. Did I use the... No, yeah, the hundreds are the non super duper audio ones that I have. 47, 470, 220. Means it'll turn off a little longer. That's 1,000. 100 was like this big. That's a 470 though. And I'm intentionally using very big capacitors in this. I mean, decoupling with a 680, those are only 10, whoa, wait a minute, those are only 10 volts. That's a 10 volt capacitor. What's the voltage output on this thing? I don't think it's going to swing 12 volts, will it? Plus minus input, the audio signal also needs its own path to ground. In addition, high value resistor between the signal input and ground, 10K, and the schematic acts as a pull down that drives the input to ground when a source isn't connected. Without this resistor, look at a loud buzz or hum if the music player isn't hooked up. Pins 1 and 8 have been left open. 100 UF capacitors placed between bypass and ground in order to prevent some power supply's noise from being amplified. The input and ground pins, the power source is fed to pin 6, 100 UF decoupling parallel to ground. Finally, the output of pin 5 is set to frequency, blah, 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 blah. Filtering and smoothing. I don't know if a 10 volt. Yeah, they don't say what voltage, huh? That's dangerous. You got to make sure that your voltages are higher in your capacitors than the maximum. With a 1 kilohertz sine wave maximum of 120 millivolts RMS, around 2.38 volts. So the 10 volt capacitors, totally in its element here. It'll be totally fine. All right, we're looking for another 100. A 100. Decoupling. That's 1,000. This one I want to be a 50 volt because I want it to be able to tolerate the 12 volt power supply in its full. $100 off, 50 volt. There we go. It's funny, the surface mount caps somehow get that capacitance in a smaller package. Slightly smaller, it's not completely tiny. Input is on pin 4. That's here. Why is there a wire coming out of it? No. It's 1, 2, 3. Hold on a minute. Why is there a wire coming out of pin 4? Oh, because 4 is not. It's 6. It's pin 6. Why am I dumb? What has happened to my brain? Twitch has done this. I'm going to get in on the class action lawsuit about streamer brain damage for spending time on the platform, broadcasting to the platform. It's been damaging me. Uh, pin 6 is nestled like way in there, and then pin 4 is actually connected to ground. So it would be pretty decent if I came in like this, right in front of the chip, and then I can bend my ground to pin 4, and then I can get this other lead. This is, oh yeah, this is the one that we put in before. All right, well, maybe we can still make use of it. Get the lead over to there. Maybe not. Maybe there's a ground wire right there. Pin 4. Yeah, pin 1, 2, 3. Sorry, 1, 2, 3, 4. God, these ICs, man. I don't know what it is about me. I have so much trouble when I have to go through hole. Pin 5 is our output. So yeah, if I'm coming out pretty much over here, I need to be over here. I'll put the first lead just right in the middle. Yeah, right in the middle-ish. Actually, a little south of middle. Aesthetically, I don't know what this capacitor is going to be doing. And then the next lead is how far away. I need to keep this in focus more. I know the circuit ends up being very small on camera, but there we go. It's like right about here. Too far apart? No, that's good. Getting a lot of miles out of this drill. There's a lot of caps in this circuit. 1, 2, 3, 4. Huh. That's not a ton, but whatever. Perfect. So now this lead goes here. Ah, crap. Might need to get another one of these if I can't make this work. FTL music in my brain. It's like a little hook that I've got to kind of hook into this pinhole, and then I need enough lead so that it can avoid it. I think I need to get another 100 of. Need to get another one. That one's doesn't have long enough leads. I overdid it. Hopefully I've got one. And you know, with audio stuff like this, I guess I could use a much larger cap. It could take significant time for the thing to start up. With chips, use a 0.1. This one's calling for 100. But with 12 volts, that's still like a millisecond for it to come up. Very, very small increment of time from t equals 0, when the capacitor is actually a short circuit and all the energy is going to go through that cap. Where did the one that just fell go? One of them just fell on the desk and I don't know where it is. Where have you gone? I wanted to put you back in the capacitor thing. There it is. This is such a simple circuit, it kills me that we're still working on it. There's a 100 UF, and it's 50 volts, and it's a silver, or a gold one. It's one of the nicer gold ones. Although it is only doing decoupling, so I really don't need to use a nicer one on this, but I guess I will anyway. It'll give a variety of... Well, actually, no, it won't. Yeah, I shouldn't use this one here. Maybe just one gold cap. Yeah, I'm gonna find one that's not, because it's not an audio. It's not doing anything with audio, so it's just making the power up sequence smoother. What was the size of it? It looks that size. Okay. So with that in mind, am I able to find one? Come on, capacitors. Just do me a solid here. If I was super serious, if I knew that I'd be sifting through every single capacitor that I own, I would probably be moving them to another bin. So it would narrow down my choices as I go through these. Another reason Surface Mount is better, because they're organized. Yeah, my buddy had me, because of the capacitor plague, he bought a kit for his monitor, because his monitor kept randomly turning off, which, you know, anybody who knows this kind of stuff knows that when you have a friend coming to you with a piece of electronics that they bought in the early 2000s that were having problems intermittently anything, you know that it is just a bad capacitor. You can pop the thing open, and because they had an error in the electrolytic solutions that they used in these things, gels or whatever the hell is in these caps, in the 90s there was a big bad batch, and it caused what's called the capacitor plague. And so all of this 90s and 2000s electronics will have these intermittent weird problems where something will just suddenly happen, and it's always the capacitor. So he brought a TV to me to fix, and he bought a kit of the really nice expensive capacitors for that specific TV, and I ended up using the less quality ones on his TV. I think it was a monitor, I don't know. But it got it working again perfectly for a long time. I don't know if he's still using it. More than likely he is not. That stuff aged pretty quickly. Come on, there's gotta be another one in here. I might have used up all the ones that I need, all the 100s. I don't want to use the fancy one. Yeah, both of the 100 UFs are used for like system stuff, not for audio stuff. So I don't need. Okay, that's on the floor. I can't win. I can't win. I can't find the cap that I need. Please send your lowly streamer a 100 microfarad capacitor. I'm literally dying. I really should have it in here. This is not a big ask. This is like a really common value, and you know, the commonness of the value is probably the reason I can't find one. Maybe I'll just use like a 220 or something. Difference between 100 and 220 is like nothing on the scale of time that 12 volts offers us. How many are we up to? Oh, we've just gotten out of the byte or whatever, the word. 1,025 times. In part, that is so inflated because of Burn the Subs times that I had an extra desk in here to build the previous version of Burn the Subs, and I was using MakerBeam, and MakerBeam is a lot of little screws and nuts to distribute throughout your floor. I was dropping things like there was no tomorrow. All right, I'm gonna put a 470 F in there. Actually, that's 25 volts. I wanna be in 50 volt territory. Let's find a decent capacitor. 470/25. 330/25. I mean, 25 versus 12, I guess that's okay. But it is right on the rails, so if you're plugging and unplugging stuff, I don't want this cap to explode. Although, if you're plugging and unplugging, the effects of static electricity would be very minor on something like this. This is 220/16, 470/16. 330/50 is kind of a big boy, huh? That's a bit much. I mean, it is a little comical to have it in there as the decoupling capacitor. Project 454, 20 months. My kingdom for a 100 UF capacitor. How calling nuts? What? Yeah, 330/50 is way too big. And I'm starting to like, my impression of the size of this thing is starting to skew. Here's a 220/50. Close enough. Okay, so that is going here. And this one lead goes to pin 4. No, pin 5, pin 6. Goes to pin 6. 4, 5, 6. Yeah, so that empty pin right there is where this lead goes. I actually have enough of this lead. Make sure it doesn't bump into anything else. And then this one goes to ground, which is right next to it. I'm going to pull that a little bit tighter. There you go. And this one can go to ground right there. Power and ground will go just basically directly into that. Just cut that a little bit. And the tweezers can barely manage the big thick wires for these 50-volt caps. "50-volt capacitor." Bendy wire circuits directly over top of melty plastic is kind of annoying. No. Need you to stay put. Just stay right there. I'm moving. It's like the least easy position to solder because this thing is like wants to go everywhere. I want to get this on camera though. I want to actually like show what's going on here. It's an extremely simple circuit, so all the folks playing at home can actually follow along. Okay, stay right there. Okay. Normally we do much more complicated stuff. This is notoriously simple. I probably could have put that a little further away, huh? Okay, and then what's left? I think I've got most of the circuit actually. Audio ground, 10 kilo ohm, 100 UF. Yeah, this is like the whole circuit right here. So I guess I can solder the IC in and then we start hooking it up to the internal and external signals. So I need to get the IC in here, which is not going to be easy. And then pin 1 and 8 are floating. The 2 pins on the end are floating. Where'd the chip go? Where'd the frickin' chip go? Where did it go? I want that chip. Find it. Bring it to me. There it is. The hard part's going to be shoving all this stuff into the holes that are already there with the new wires sticking out. Yeah, bend the leads away a little bit. Might help. I love how I'm bending on the leads and then the components move. Not exactly dealing with the precision of a normal circuit board here. This is a hand-drilled nightmare. So everything is sort of a little bit out of place. That makes it a little difficult. But it's a fun challenge. Ah, damn it, I moved. Moved just a little bit. These need to be like perfectly aligned in order to fit in. Because I'm doubling up stuff. There we go. Got him. Pin 8 is like shoved all the way in there. Ah. Alright, so then I just can solder these up top. We'll be all dandy. Of course, I'll clip them a little short too. That was a pleasant little circuit to wire up. Usually they're much more of a pain. But this thing is an ASIC. It's meant for one job, so all of the stuff is bespoke. Okay. Clip these short. Hopefully don't clip the leads off. God, that would be terrible. If I just clip off one of the legs of the IC. You ever have to repair around that? Where you sand open, you sand into the epoxy case until the base metal of the chip is revealed. It's there's like, because inside of the chip, I mean the silicon itself is like teeny tiny little wafer, and then all of your leads are in this epoxy casing. They go up and in, and then they kind of route inwards, sort of like car circuit boards where they're made out of plastic. So if you accidentally bend off a lead, which happens a lot because you get like 1 or 2 bends before these things break off permanently. 1 or 2 bends, so you absolutely have to use that chip. You can scrape away the epoxy and still get, usually there's like a little nub left, so if you scrape around the nub, that'll give you a place where solder can, you know, make a tiny little bit of a connection. You gotta do it. You gotta do it. All right, so let's get these leads soldered, and then our amplifier should be good. Now, I hope this thing doesn't run hot. There are heat sinks included with this kit of amplifiers, but shouldn't need them. It is only really running a watt. A hot watt. That's funny, the yard people should be around today. I haven't heard anything, though. Should be 10,000 leaf blowers out there. Today is Hovercraft Day, after all. They were here on Tuesday, of course, to totally ruin the stream. Give me fucking exhaust poisoning. Because there's not a lot of air that comes into that alleyway between houses. My only air supply down here in the submarine basement. I'm going to clip these to look a little nicer. Can't get to them all. That'll be okay. All right, so our circuit is wired up. It's simple enough that things aren't completely colliding. I probably should have pushed that one in through a little bit more. Okay, it's all right. That's all right. Yeah, it's a little sloppy in some spots, but otherwise it's pretty well done. So we've got our audio input, our speaker output. Speaker output goes through the capacitor in this direction, yes. And then they got the 100 NF. Oh, wait, I put that directly to ground. Dun, dun, dun. There needs to be a... Oh, no, that goes directly to ground, yeah. 1,000 burnt fingertips and a long time experience, yeah. I don't know how you do floating circuit soldering. Not well. Not well. I do much better when I have a perforated prototyping board, because this is not my best work. But the circuit is so simple that it's hard to get wrong. So we got our input going in here, going through the resistor in kind of a bonkers way. It kind of goes backwards. I could flip that resistor around and, well, no, actually, no, this is fine. Yeah, the 10 kilo ohm goes to ground, and so there's the ground plane there coming from the input capacitor that also goes to the power input. So power will go across those two leads down there, and then our output is on that pin. No, actually, that pin is a 100 microfarad capacitor that goes to ground. It's just something to do with the power supply filtering. Ground also goes all the way out there, where it goes through a 100 nanofarad. Sorry, that's the 100 nano. The other one's 100 UF. The 100 nanofarad, however, goes between the output and ground for just a little bit of filtering. And the output also goes through the big boy, the 1000 UF, where it's going to connect right there to a wire. Lay out an LEDs for Gerber. It's, look. This is a dead simple circuit. It's very easy. Totally unintimidating. Oh yeah, we need to do power actually needs to go to here. How do I do that? I guess just a bit of a thicker piece of wire would do. So let me go get a thicker piece of wire. What did I use before? I think I used a little thick piece of wire. Yeah, this guy. Although internal wiring parlance would say that I should not be using a black wire on anything but ground, but everyone's a critic. Oh my goodness. Dog just totally let loose on somebody out there. Bow! It was like a howl. She's howling into the night. I can't believe Halloween's already over. When did that happen? It's only just over, but... Can I get good at this by burning a bunch of other people's fingers? I mean, we weren't, you know, that's kind of, listen, that's an industry thing. That's an industry thing, and we don't like the hobbyists to kind of know about that, because, you know, that's something special. I'm going to have to send a cleanup team over to your place. It could be. I could make it into a sugar skull. I need markers. I need paint markers. Yeah, we haven't seen Willow lately because she's been a jerk. I don't know. Got a little personality, that one. She just, she appreciates barking. Or when she's down here, she's sort of made the downstairs couch. There's like a TV area down here, and she's kind of made that into her little den. So there's all these dog toys and stuff. It's my birthday present that I won't be getting in the mail. 12:01 on November 1st. What? Yeah, I got that early November birthday. Told my parents I never want a Halloween themed birthday party because I thought I wouldn't get as many toys if it was Halloween themed, which was dumb because Halloween rules. So why would I not want to have a Halloween birthday? What the hell's wrong with me? What did I tell my parents? It's so dumb. Oh yeah, we got daylight coming up. That's another thing is like we're out of sync with all the other DSTs. All right, purple's input, green is output. So input to here. Although quickly that went. Oh man, I just burnt the seam a little bit. I should have done this from the get-go. Nice and easy. Oh, I have to also ground these two, huh? Well, where can I put these? I'll just put them over here. Put her there, Pally. Let's pre-tin that a little bit. Brother just used to calling the devil child. I never got cool treatment like that. Problem was, throughout my whole life, I was the oldest. Oh shit, the oldest person in the room. I just wasted all that solder. Yeah, I was like old for my grade and stuff. I was the first person in my friends group to turn 21, so we had to go to like Bennigan's or some shit like that. All right, damn it. Okay, so there's our LED ground. Those are after all the circuitry too, so maybe they'll flicker a little bit. We won't really be able to see that though. Actually, this ground should be connected. That one's power. This one's ground. It would be nice to connect it down here, but that's kind of hard to solder. So I'm going to go up here, which is really, I mean, the ground and power should be hitting that capacitor first. But it won't, because we can't have nice things. All right, this goes here. Oh, this is on the wrong pin. This actually goes down here. Working on this kind of stuff and talking to you guys and trying to keep it at least a little bit interesting is it is difficult to do. I've learned how to do it, and I've been forged in the fires of streaming, but it leads to silly little problems like I'm experiencing right now, where I wire something up wrong because I was distracted. Yeah, and by the way, you're not a devil's child, you're a Valentine's Day child. Don't do the math. This November birthdays have the curse of Valentine's on us. Shit, fuck, shit. Is on a 3.5 millimeter jack. It's in the other part of the skull. We've already wired it up. Fuck, god damn it. Stay up. Just stay, don't move. You son of a bitch. Okay, hold on. I'm gonna pre-tin this line so it's easier to solder. Come on. Well, I mean, that's literally what I'm struggling with right now, yeah. It did work a little bit in the soldering stand, but oh, I just melted the crap out of that right there. A lot of plastic smell. I just want this to be done. I just want this to be done. We have a VCO that we need to tune. Dang. Output wire. Please. All right. Input, output, all the other connections are made. No flying leads. Everybody's happy. Everybody's compatible with 12 volts, barely. We haven't used any hot glue yet. That's how we're going to put the teeth back in. Only once did I manage to solder a 3.5mm jack in order to make an adapter for an 8-ohm speaker. There's all kinds of different 3.5mm jacks. I mean, you have these, which are poison. They're made to be like Donkey Kongs, but through hole. There are the Donkey Kong jacks, which are common in modular synthesizers. These are dead easy to solder. Problem is the plastic on these is melty. And so if you're working on these specifically, the missing feature on this 3.5mm jack is something down here to stabilize it. So when you put the nut over the top of this thing and you tighten it down with even just finger tight with a torque wrench assisting, it will actually pull this piece of metal out of the thing that holds it together and destroy your jack. The Donkey Kongs, on the other hand, they have a little shoulder, and so the brunt of the force is on that shoulder between the panel and the jack. There are other styles though, and we've used a couple different ones in the, well, we did use the Donkey Kong in this one just because I happen to have 10,000 of the things, but we also have this style of jack too. And there's a ton of different styles of jacks out there. So yeah, that's just dead easy to solder. And that one's actually going to two 2 kilo ohm resistors, and then our output. Everything is a little bit sloppily soldered in this project. Everything's a little sloppily soldered. It's not really meant to be an award winner, this one. If any award-giving agencies feel like giving me awards for this, you know, I'm happy to accept, but the magnet on the speaker has picked up all my cuttings. Disgusting. I would love to get an input monitoring thing on this, but I think that might require me to put an op amp in here, and I don't know which op amp I'd use. Maybe a TLO74, and then have it do clipping, but it's not totally necessary. And if I really wanted to get crazy analog with it, I could probably bias a LED to like react to the music. That's a lot of hubbub though. Now this should by all means fit together every time. And so there's a little bit of a gap up here. Oh, that would have looked so much cooler without all this mess. There's still some stuff I can do to hide this stuff, but like if that were just clean skull right there, I could put a Band-Aid on it. Or maybe another IC over there. Because yeah, that's what I was kind of going for with the original Skull project. Cyber Skull. Well, let's see if it works. That's going to be stressful. Turn that off. We're looking for heat because we have a thermal camera, which means we can look at heat. If you don't have a thermal camera, oh dear God, dude, you gotta minimize those. That's way too much link text. Yeah, that's what I have. That's pretty much exactly what I have. These are easy to solder to. You just don't want to use a big soldering iron. Sorry, that was confusing because I burped in the middle of it. That's true. I can put extra components. I might actually, that might be what we do. The thing about soldering audio jacks is they're using cheap plastic on it, and they have big tabs. It takes a lot of heat. It'll hold a lot of heat, and it will distribute a lot of heat when you're soldering. If you have one of those little heatsink clips, that can help you out. Generally, what I do is I use a big soldering iron that's turned up to my normal temperature, because I have the Pace soldering station, so it's always at 666 degrees Fahrenheit. Spooky. Anyway, it's always at 666 degrees Fahrenheit. I use a big iron because that has a lot of heat capacity. And when you attach that to the pin, you want to make sure to get your solder in there. If solder doesn't really transfer, or if the heat from the soldering iron doesn't really transfer, you start a little bit of solder on the iron, and that gets the little tiny bit of rosin flux to flow out, and that'll heat up your pin. And then you apply the solder to the pin, and you get the hell out of there as soon as you can. Pre-tinning helps. You put the thing, and you know, I'll put it in a vise to hold it steady. Put it in a vise to hold it steady, or you put it on the panel and have something holding the panel. Once you get that pre-tin on it, then when you go into solder it with like a wire, you just very quickly melt everybody together. Get the hell out of there, right? You get the hell out of there with the heat, and you wait. You have to wait. Sometimes your hand will be burning and you will be waiting because, and again, like I said before, those pins, they're big, they're wide, they hold a lot of solder, they hold a lot of heat. They hold it for a while, metal. You need to wait until that solder recrystallizes, solidifies again. And sometimes that means the what you're holding on to gets pretty hot. But yeah, I've soldered them in all kinds of different places. I did that why is the audio crunchy and looked at the jack and it's all wonky. Oh no. Yeah, this is a test noise circuit that we built on the perforated prototyping board. But yeah, I've soldered these in all kinds of different ways. They're all right, nothing special. They aight. All right, so what we're looking for here is heat, but also if you don't have an expensive $300 thermal webcam, because it's $150 for the core and then another $150 for the group gets. I think it's an STM32 project actually. But it's like a webcam driver that does the high FPS. That's really important in this, is to have that FPS. If you don't have that, what you can have and should have is a variable power supply that tells you how much current is being used. That's what we have here. I have helping hands, but I have a hard time on gripping. I hate helping hands. I don't like helping hands. There's this one thing that has 4 little pinchers that I think might be a little useful. And it's got a big aluminum, like, X-shaped base. What I use, and it's not something that everybody can use, it's a Palmgren precision miniature vise. I looked this up once, and it was worth $600. I got it probably from a dead guy because of all the machining stuff, estate sales. So we're at 6 volts right now. We're going to test this at a lower voltage first. I still have this thing able to deliver 6 amps. I could turn it all the way down to 1 amp, but it's more fun and funny if things explode. So we're going to do that. And we'll just see if this thing pushes any current through it. And then we can test it with a whatever kilohertz wave coming out of this VCO. That's what we're going to work on next. That's right. Gonad uses a big chunkus of blue tack. It looks like he's ripped a little bit of his own brain matter out, and he has it sitting on the desk. I saw that in the picture that he shared a little while ago. It's just this, it's this big lump of, it's like in the Plinkett reviews when he goes, you know, you may not notice that, but your brain did. And he shows that picture of that little kid working with Play-Doh. That's just what it looks like, only it's a little blue, sort of blue-gray. It's horrifying. I'm tuning in at a good time. Yeah. Well, one thing is, just in case anything blows up or lights on fire, you want to make sure that, you know, you get the knife blade off of the desk and stuff. So I'm doing sort of a little partial cleanup here, just kind of scooching stuff out of the way, just in case I have to throw sand onto my desk to put it out. Usually that's not the case. Ah, that was a pin tool. I got a right angle at the end. I can't watch other creators because I'll take on all their mannerisms. Start talking like Gonad or using all the AVE-isms. Those AVE-isms are poison. His whole, look at his subreddit. It's ridiculous. It's impossible to tolerate. It's like everybody's trying to sound like a rugged Canadian in that. It's intolerable. I went on that subreddit and I was like, ah, just like immediately left. I'm going to put the screws back into this thing because this thing will be useful at some point. One of those things. You're Canadian. I see. Well, how cringe is it for people to talk like that? All right, this should probably go in one of the through-hole bins, but I'll put it up here for now. Okay, let's get this thing fired up. Still more garbage on the desk. I have to do this. I have to pack it all away. Get all the bins out of here. This has been a pretty handy-dandy little kit. I mean, it's got a big variety of amplifier-y kind of things. There's a PWM controller down there, huh? I wonder if I could use this PWM controller for my pulse-based counting MSG EQ7 module. I think I could. That would simplify it pretty effectively if I turn that pulse into a square wave and just had a counter counting every 7, and as it does, it would hit one of 7 sample and holds. Originally from New Brunswick. It was pretty accurate for the Maritimes. Okay. He's also a crazy person, a pants-on-head crazy person. Okay, so let's do, first of all, just turning it on and seeing if it explodes. Watching Moon is the worst. I regularly say Giga and Omega. I watched Moon for a little bit. His My Summer Car was very funny. And the funniest part about watching Moon play My Summer Car is that he has music going on in the background, but I'm watching all of his VODs. So the VODs, he will just blurt out some song lyric completely off key. And while that sometimes is okay if you're actually listening to the song, having him just blurt it out makes it seem like he has a very serious mental illness, and it kind of adds to it. It adds to it. It's kind of fun. All right, currently off, hooked up. Power is now on. I am getting no current draw. So what I'm doing is I am observing carefully the amount of current draw on this. Arduino as text-to-speech, imitating a speak and spell voice. I actually have a speak and spell circuit board. It's down there. I was going to try to get that working, but the speak and spell, the way that it does like the vocal isms, they're like little pieces of vocalization. You have to like string them together. It's very complicated. I tried to read about it on stream and I just didn't get anywhere. It was a very boring stream, actually. I was going to try to take over a speak and spell with an Arduino, and it was just so complicated. The projects that we're working on that kind of stuff are probably a lot further along now, though. Yeah, I need something that'll gloss over that. If I could somehow have a volume level indicator, that could go right there. I'll figure it out. Aesthetic perfections lax. Interesting. Okay, so we're powered on. I'm going to turn this switch. We're going to see if anything heats up. All right. Thank you. My heart will never recover from that one. Uh-oh, that's getting a little toasty. This isn't drawing any current. All right, I'm turning it off, and now we're going to try it with audio. I mean, it got toasty, but it's only got 6 volts. We're going to be putting 12 volts into this thing. Huh. I wonder if I need to put the heatsink on it. That would be kind of fun looking. Audio. Yes. From here. Yes. This one I can turn on because I know it works. And then I can take the sine wave output and put it into our input here. I don't get why it's changing pitch as... Okay, so that's very, very quiet. I can hear it. Maybe the clipping protection is coming in to play. That's getting very hot, though. Ow. Jesus. Why is it getting so hot? Why does all this stuff heat up so much? Ow, that's hot to the touch. All right, turn that off. What did I still do wrong? Oh. With the circuit off, it's still, I can still hear it. I can still hear it. It's not amplifying anything. Why do you not amplify anything? Why am I still hearing buzzing? I'm still hearing buzzing. This thing is off. Okay, no more buzzing. Was that a ground loop buzz? So the speaker ground is the same as the rest of the ground and the audio ground. That's connected to there. That's connected to there. This has a pretty big resistor on it, which I could change if I really need to. But we weren't getting any amplification and our circuit was heating up. So I've got 220 UF 50 volt cap. The positive there. Hold on, I'm double checking my circuit. Positive switches on, goes to the sunglasses as well as that cap. It doesn't look like there's anything shorted out there, but it goes to pin 1, 2, 3, 4, 5, 6, which is correct. I mean, there's not much to the circuit. I don't see why it wouldn't work. And maybe it is working, but it's getting very, very, very hot. Very, very, very hot. Voltage in your coils inducing a current. No, it was something leaking in from the power supply somehow. And I don't know how that works because I hit off on the power supply. Flyback wouldn't be a tone. Flyback is like a big pulse. Control F, heat. I can't control F. Let's see. Does he say anything about how hot this thing gets? Plug in an old 4 ohm or 8 ohm speaker that I did. Audio source and slowly turn up the volume. Experiment with different styles of music. See if you can get detected by clipping. Try the circuit without the various filtering. It could be. I think there's also bleed through, so. If I put a 10 UF capacitor between pin 1 and 8, I'll increase the gain. The circuit through a spectrum analyzer. 707 milliwatts of power, significantly exceed the rated output. To be fair, I was pushing it harder than I recommend. Well, why is it getting so hot? That's weird. Small collection of audio test equipment I put together. Got the following results. 8 ohm dummy load. This guy was like hardcore testing this thing out. Yeah, TDA 2050, a 32 to 35 watt mono chip. Heading into audiophile territory? What? Really? We were going to use this. We tried. Wait, 2050, not 2030. Never mind. LM386, most widely respected grade, DIY, hi-fi grade, blah, blah, blah. Get a fat heatsink for the LM386. But this one, he doesn't mention anything about heat. Why would it be getting hot? Why am I cursed? The Skull speaker is cursed. Why would you be getting hot? And oh, it also showed it not drawing any current. It said it was not drawing any current, and yet the chip was getting enough voltage for it to get very hot. I mean, like burning me hot. And I wire it up backwards? I don't think so. Hold on, let's double check my power here. That's one of those things, is like sometimes you'll hook something up backwards and that's the source of all of your issue. Look, this is the second day in a row you've said maybe the plastic is conductive. It's not conductive. Look, I have it on ohms. Oh well. The specialty of conductive plastic is far and away beyond the cheapness of the manufacturers of this speaker. So there's no chance. Volts. Ah. So like you know how yesterday the circuit was heating up for no reason? Here's your reason. See that little tick? That little tick right there, that little thing, that little sign. Yeah. Okay. Yeah, I put this backwards. I have a feeling that our circuit yesterday would have worked just fine. That's on me. That's the kind of stuff that you get here on Twitch. YouTube, I would have just glossed it over. Here, I have to eat crow. Actually, no, I don't have to eat crow, because nobody else told me that that might be what the problem is. But that's a very common thing to have happen in your projects, is you overlook one little detail, and it just takes one little detail. You overlook, I don't remember the way that these were wired. Shit, I gotta ohm it out again. One little detail. Yeah, Demi, I was being pathetic at the beginning of stream and being like, I need your subs in order to continue, as a joke. And who was it? It was where's my Streamlabs? I can't remember all your names. Wayne Johnson gifted a sub sort of to play into the joke. But yeah, this kind of thing happens. This happens. You'll do it too. Mark my words. At least now we know why the other circuit was dead. It's a shame, though, because I could have fully implemented that circuit and it would have been fine. I guess it looked a little sloppy. This one looks a little cleaner. Oops, wait, I'm going from here to meow. Okay, so the solid one goes to ground, and the stripes go to center. You missed it? It was wired backwards to the power supply. I hope that means I didn't blow up my chip. Hopefully the chip is a little more solid. And to do this while doing it on camera. Ah, my glucose level's falling. I can tell because my hands, when I put them in funny positions like this, they start to, there we go. Oh, they start to cramp. It's just a weird, it doesn't hurt. It's just a weird feeling. It's like your fingers don't want to close. You gotta like, yeah, that's why the diodes were heating up, is because we were using them exactly the way they were supposed to be used, just in the wrong direction. And so they just basically shorted to ground through their own silicon design. Okay, well, let's see what kind of reverse circuit protection exists on this thing. Actually, before I do that, I should just test. Just to make sure. Just test setup problems. That's what it always is. So we go positive here. Oops. That's weird that it said it wasn't drawing any current though. All right, 6 volts are now on the proper pins. I didn't damage this thing too much. 6 volts to the proper pins. Go. Go. Let's turn it off first. Power off. This thing is such a pain in the ass to plug in sometimes. There we go. Okay. It is drawing current, and it's still at 5 volts. This is getting warm, but not hot. And so if I give it audio to play, it doesn't seem to be getting any louder or softer. That is very quiet. So, this is what it sounds like. Hold on. Try to get the halves back together. That's it. It's very quiet. And it only changes as I move the knob. It's like changing, it's not changing its volume. Yeah, at least it wasn't a motherboard. Well, at least it is amplifying. So maybe I need to give it 200 gain. Oh, the cap is getting hot. Ugh. Turn it off. Turn it off. Turn it off. Is that the big boy? No, it's actually the chip. Just the chip is getting hot. Yikes. That seems like it's a little too hot. Yeah, it's like it's warm. It's pretty warm. So if I put a 10UF cap across those two pins, it'll get a much higher gain. I don't know if it's heating up like this because of damage, but when I turn it on, it's makes some weird noises, and I don't know why. This thing is like 6K, this volume knob, so it should by all means be turning the volume up and down. I guess it kind of is. It's just hard to tell. Yeah, I can barely hear this. And what if I short out the resistor? It makes a different tone? What? This is a pretty loud source. Yeah, this is a loud source. Well, let me let it cool down a little bit here, because that's pretty toasty. What is toasty over here? Oh, it's the that's right. The amplifier chip on this one gets warm. It doesn't get bad hot, but it does get warm. Now, what if I drove it off at 12 volts? What's going to explode? Okay. 12 volts doesn't make much of a difference. All right, so we'll keep it on 12 volts. I'm going to take the 6-volt supply out here. It's still very, very quiet, though. I don't know what's going on with that. The caps aren't what's getting hot. It's the chip here that's generating quite a bit of heat. I don't really think that should be. I think I've got wired up pretty good. Do the sunglasses come on? Yeah, those are there. There's a little bit of a ghostly light. Yeah, it's true. The amp might be... it's not making any noise right now. It's turned off. But when I do turn it on, it goes wee. It makes this very high pitch noise, but not loud. What happens when this thing is hooked up backwards? This is a different chip. This is the HT8961. That's not the right one. LM386. Wide supply voltage range, 4 to 12, or 5. Is it 4 volt to 12? That's not negative 12. Yeah, 5 to 18. Low quiescent current drain, 4 milliamps. Yeah, it's getting too hot, though. I know, batteries versus PSU noise. It's fine. It's not the... Hold on. Ground reference input, voltage gains from 20 to 200. Self-center output, available in 8 MUSOP package. Designed for use in low voltage consumer applications, the gain is internally set to 20 to keep external part count low, but the addition of an external resistor and capacitor between pins 1 and 8 increases the gain to value from 20 to 200. The input's ground reference. Output automatically biases to 1/2 the supply voltage. Quiescent power drain is 24 milliwatts, operating from a 6-volt supply. Good for battery operation. I don't see anything about reverse current. Yeah. So we might have killed the chip. Everything is wired perfectly. Everything's in there and wired perfectly because I'm perfect and I don't make mistakes. TOC. Thermal information. These are always in Greek, though. I can never understand them. 4 to 12, 5 to 18, quiescent current, voltage, bandwidth. And then here we have thermal information, thermal metric, LM38, SOIC. Actually, it's PDIP. It's probably fried. We're getting to that conclusion. Degrees Celsius per watt. 42 Celsius per watt. It should be way less than 42 then. That seems like it's busted then. We must have reverse currented it and blued it up. Yeah, that's pretty serious, isn't it? That's weird. I just reverse current is enough to just totally take it out. So the cleanest way that I can do this is by snipping off the leads and then desoldering what's left of the pin from there. And then we can put in another LM386. Luckily, I've got a couple of these. Actually going to put some screws back on this thing because it'll stand up on its own. I'm so cursed. Yeah, the thermal camera is amazing for this kind of stuff. That's why I have it. That's why it's paid for itself, even though it was 300 bucks. Yeah, that's exactly what I'm going to do. Except that I'll pick out the old legs. Yeah, it's like when you blow them up, they create these little internal shorts that mess you up. It's something that I didn't expect to be so useful, but OctoJ, my original moderator and the person who has been watching my show the longest, he was so sick of me burning myself on everything. But like, you have to have asbestos fingers if you do this kind of stuff, right? You just gotta. But at the same time, you know, he's like, you keep burning yourself, like, don't. So here's a thermal camera, and he funded half of the thermal camera build. But now that I have it and it's functional, you gotta get that frame rate. And I think that you know, it's no longer other foreign companies have now started producing thermal imagers, and so we're not limited by ITAR. But ITAR for a little while was an SOB. They kept us from having high frame rates because they didn't want us putting thermals into missiles and stuff. But now there's other companies that are creating thermal imagers that have higher frame rates. We don't really need anything above what this thing does. So yeah, it's a new fast one. Yeah, international trade restrictions said that you know, because we were riding mighty on that thermal wave. We had all that military supremacy in our imagers. But yeah, this frame rate is just fine for this. I have another entire thermal webcam unit, and what I need to do is figure out what lens system I can use in order to get a zoomed in image. And if I can zoom in, then we can have a thermal microscope as well. I don't know what I can use there. It's like you need long wave infrared optics, LWIR. And once again, because it's thermal stuff, it's really, really expensive. So The Apprentice to burn his hands on the board. Feel around and see if any of these ICs are hot, or else you're not going to get credit this semester. I gotta work quick because this stuff is all in contact with the plastic and melty. All right, so now we get a new IC in there. High res, high frame rate. I mean, we don't really need high res because it's always going to be inside of a little window, right? Let's see. Oh, you mean ITAR? Yeah. But foreign companies are making better ones, so now you can use those. Even though we're still restricted. The ones that strap to your cell phone are getting pretty cheap. Even the Lepton 3.5 module that I use is gone way down in price. It used to be much more expensive. I got the current one off of eBay for 150 bucks. All right, so that goes in here. Got to install a new chip into the skull. I guess this would be an argument for using sockets. Socket would have made this trivial. What I'm going to do is I'm going to bend the leads with the tweezers in order to get them into all of the crudely drilled holes. That one's got to reach way over there. Man, I got to start thinking about Thanksgiving, huh? Might have to drive down to my brother's place. Because apparently the in-laws are making all the decisions these days. But when I stay there, there's always other people staying there. They have like a whole suite for guests. And I don't get to sleep in the suite. I get like a couch in the basement that doesn't even fit me. Like a child's bed. And they're like, why don't you like to visit? It's like, what do you fucking think? Like I'm going to prison. Worth it to see the kids, but not much after that. Why are you not going in? One of the pins isn't quite lining up on this side. I think it's this one. I could just heat them up and sink them in. Why isn't that going in? That should, by all means. This is where my hand slips and I end up perforating myself a couple times. Maybe the pin tool will help. I think it's stuck on the... I get the dog's bed when I stay at the parents' in spite of there being 4 bedrooms. It's like, they're like, what? It's a bed. And I'm like, no, my legs are dangling off of the end of it. Like, I don't think they've ever tried to sleep in that. You know, one of the big tricks about adulthood is if you have a guest room and you expect people to be staying in it, you need to stay there a night just to make sure that it's hospitable. Need that data point. Why is this not sinking in? The whole other side is ready to go. This one is just not cooperating. One of these pins is fighting me. Wait, is this an LM3? Yeah, this is. Okay, I had to make sure it was the right chip. I think this one's just not fanning out far enough. My holes are, of course, drilled all over the place, so... What the hell? Okay, hold on. Just have an expensive bed for my older dog. I'd sleep in that shit all the time. Yeah, some of those dog beds are actually pretty comfortable. The one Willow has under my desk is an unexpected winner because it looked like it was too small for her, but she really likes the constriction. She likes to curl up in a ball and then tuck her nose into the edge of the bed. Because her first dog bed was one of those giant gray ones, and she just kind of sinks into it like a giant marshmallow, which is cute and all, but having a bed that's more her size is good. Oh, this one is bent too. No, that one's working perfectly fine. The joys of a DIY drilled board where the drill bit is never quite in the right spot. This kind of feels like when you build your own circuit board. My face when I build my own circuit board. Okay, why isn't this going in? See, the problem is if I slip, then my thumb is going to go right into all of this stuff. Ah, it should be so easy. They look like they're positioned properly. Yeah, you know that sleep thing, the sleep button that people are advertising instead of CPAP? It's a 10-year medical appliance. So after 10 years, you have to get it changed out. Sorry, I can't keep my hands still enough to do that camera. You just got to look at the fine print on those things. I was thinking about seeing if I could get that. I don't know. I don't know about it. I don't know about a 10-year medical appliance in my throat. And it's an outpatient install too. Okay, what the hell is going on? Why aren't you going in there? Go into your holes. Let's start this side over and see if I can figure it out. Okay. Yeah, maybe that one looks like solder's blocking it, so that maybe that's the issue. I can just get a few beers. Let's see about that. Yeah, when I drink too much before I sleep, I snore really loud. And then I wake up with a sore throat. And everybody in the house is worried about me. All right, let me straighten these pins out. Something like this is good at straightening pins. Because sometimes you need to just crush the metal to get it to go in line. Go. I think I over-rolled it, and that's why I was struggling. And then this faces this way. Just bent them. Bent the pins again. There's not a lot of wiggle room in this. Actually, I lost a lot of the wiggle room when I soldered it, because the solder pushed it into the plastic. You can hear your neighbors snoring. Oh my god. Call a noise complaint. Actually need another hole for pin 8. I'm going to put another hole for pin 8 over here. That'll just make it a little bit easier to operate. And pin 8 itself will cover over the hole. Try to do this without breaking any of the connections in there. Okay, there's a new hole for pin 8, and that way this side of the IC makes a little bit more sense. Yes, that's good. Well, that one already sank in. It's this one that's fighting me. Looks like I hit all the holes. They're just not sinking in there. may have to heat them up and pull them away a little bit in order to open up the pinholes. Or I could use the pin tool, actually. Let's not bring heat into the equation here. Instead, I can just press on the side of this in order to open it up. That might actually be better if I use heat. Okay. Yeah. Sorry, I'm looking down at this. I'm not looking up at chat. What was the comment? What's this spherical thing? Why does the components on the outside? Yeah, Demi cleared it up. This is a Skull speaker, as you do. And I am putting components on the outside because it's cool. Just a normal prototyping skull. This is a professional skull. Or maybe the skull was from a professional. Now it's a prototype. Look at me, I'm just a prototype now. Anybody missing a skull? Need a skull? These IC pins are very mad at me right now. They're not really going to take much more of my BS. Oh, there it goes. Oh no, it's bending a pin. Shit. I hate that feeling. We got to be careful when bending these, because these don't have a lot of bends in them. They'll fall off after a little bit. I'm kind of pressing my luck right now. We're just playing the odds. Statistical probabilities of pins falling off. This is smaller than a person's skull, so it's actually much better. But yeah, Demi does some damn near professional Halloweening over there. I mean, I could either heat them up, or I don't really want to heat them up though. But there's a big blob of solder right underneath this one. That's why it's not sinking in. The other ones are fine with it. Circuit bend Casios or video mixers with different knobs where you don't expect them. Yeah. Yeah, when circuit bending, you do all kinds of stuff like this. That might be part of the inspiration. Okay, I need to heat up the pin and move it out of the way. There's a spare dodo in my garage? What? Is it an actual stuffed dodo? I think I had a science teacher that had one. The dodo was such a chill bird that it would just walk up to you because it had no natural predators, and so we destroyed them. Need you to move away a little bit, buddy. I guess I can move them completely off of the hole, and then it'll just sink right in. There. Just kind of move it to the side and melt it so that it moves away from the hole. Wait, what? Needs wings and legs. Oh my god. That's what an old boss of mine did with a duck, a stuffed duck that he got at a dollar store. I have a picture of it somewhere. He got it at like the thrift store or whatever, and he added like a jet engine to it and stuff. A little casual taxidermy. All right, so this should by all means work now. Why did that one bend so much? What the heck? I'm having the worst luck with this. This went in just fine. Fire-breathing RC duck? No, I haven't seen that. I think I would remember if I had seen something like that. Okay, ooh, getting mad. Let me pin test these with this pin. That one works if I line it up. That one will also work if I line it up. Okay, so this will work if I can. What about this one? Yep, that one works too. All right, so using the last remaining pin on the dead chip, I was able to test that this will in fact work if I can get them all. Where did the chip go? Where did it go? There it is. No, what I'm trying to do, because basically the holes that I made are completely cursed, and I've run resistor wires into the holes. So what I did is I heated up these three and moved them out of the way. So now I just need to get it to line up with these cursed hole positions. Once I do, it'll insert into the thing and I'll be able to just solder those legs back on. I just needed to make sure to clear enough space. Because they had been previously soldered, there wasn't space. They didn't quite line up. Hold on. Didn't quite fit, is what I meant to say. So now I just need to guide these into the holes that I've opened up. My tweezers. All right, so lift up that end, square these up a little bit more. It's just that one in the back that's not getting to its mark. It's smark. Like, I don't want to force it down too much because then it'll do what it's doing right now and pins will bend upwards. Damn it. This one got caught. Should have used the socket. Why isn't that one going down into the hole? It's like bending the pin over and over again. Damn it. I don't have that many bends in this pin. Like, all the displaced plastic is causing issue. Yeah, I could have done it more like with an extra set of holes and then bend them down. I could have also put it in a socket, which would make it look a little bit more old school. I could still do that. Oh, damn it. It bent the pin again. Oh my god. You little bastard. That pin is probably getting pretty fragile. Getting sick of being bent back into place. Jeez. Then the whole thing. Ah. That was your title yesterday, yeah. Damn it, this shouldn't take this long. This isn't the one where I have two holes. I have only one hole there to use. It's just, for some reason, this is harassing my pins and bending them all over the place. And then the other side flops in immediately. All right, get those two lined up first. That one appears to be in the right spot. Twist this into place. There we go. There. Now it's down and in. Jeez. That was tough. That thing did not want to cooperate. Still doesn't. Okay, now I can get these soldered. I can bend them back over a little bit. And then solder the wires directly on the outside here from the top without taking the whole thing out. Whew. That sucked. All right, next. Needs to be lined up just a little better. This is through-hole stuff, so you can do a lot of weird things with it. A lot of space around everything. That one doesn't want to cooperate. All right, hold on. This one has been kind of a pain in the butt this whole time. There we go. All right, now everything inside of the skull should all be wired together. We've double-checked the circuit. It's so simple. Now let it cool down so that we can actually see whether or not this thing gets hot. Oh, there's Short Lurker finally in the YouTube. All right. Skull Speaker, One Stream Project, Part 3. The end part where I put everything back together and we have an actual amplifier on this speaker. I'm going to let this cool down a little bit further. Put this in the right way, right? Yeah. How simple can a circuit be that I can get it wrong repeatedly? Blowing on it is not really helping, is it? Well, I guess I could be impatient and just plug it in. Oh yeah, I can't see how much current that's drawing if I do that. I don't really feel like there's added heat. Let's use this lead, which will allow me to put 6 volts into it and observe the current. Okay, it's drawing almost nothing. Plug it in here. Now it's drawing current. I'm getting the same amount of sound out of it. Try over here with smaller resistors. Yeah, same thing. What's weird is this feels like it's changing the tone. That's much warmer than it was. What the heck? I know for a fact that I'm not reverse currenting this thing. We tested this. Hold on, I'm going to check again. It's reacting exactly like the one that we reverse currented. DC volts, red on the pin. This one will be 12. 12.19, all right. And this one should be 6. 6, okay. So we're not reversing it. But it's getting very hot. Why is it getting very hot? Also, the tone changes when I do that. Huh. Oof. No, this is open. We've got it wired like the first example circuit. in the datasheet, although not exactly. Well, they have a 10 UF there, pin 1 to 8, which I feel like trying, but according to the Instructables project, they have nothing between pin 1 and 8. So if I put a capacitor, if I put a 10 UF capacitor on pin 1 to 8, I guess they want a 1.2K in there as well. I can do this with surface mount parts just real quick, just to test it. I don't think I have a through-hole 10 UF, but I don't know why it's getting so hot. That's the concerning thing. So 10 microfarad, 10 micros, that's a lot of microfarads. I have a 10 UF here. Okay, well, guess I have it. There's a 10 UF. And then they want a 1.2K. That's with 50 gain. What about low distortion power wine bridge oscillator? Huh. Yeah, maybe just a 10 UF between these two. How am I going to wire that? I guess I'll just go over top of the chip. I don't get why these circuits have been so disappointing. Is the speaker? That's all off. Okay. It's still kind of toasty. So let's make it a 200 gain amplifier. I mean, the big resistors on the input are maybe what's keeping it from being loud. It just feels like we're same thing over and over again. The circuit is so simple. How competent I am when suddenly we're working with surface mount. Shit. Oh, no, no. Oh. And flush cutters, and then I'm just going to do thing sticking up on my nail. There we go. Like that, and then I'll just go across my leads here. Go. That'll do. Just don't knock it over. My iron turned off. Damn it. Come back here. Surface mount. Come on, 10 off cap. All right, so that's a little sloppy, but we've now got a 10 microfarad capacitor across pins 1 and 8. My dog going psycho outside. Oh, whoa, 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 whoa. I want this to cool off a little bit. All right, well, let's try it. Well, I don't know if it's getting hot. Do input. So with 200 gain, I'm still not getting... Wee is all this thing is doing. It's weird though, it like changes, the audio is changing as I... I don't know what the deal is here. I'm not getting any power out of this thing, and it should be, while it shouldn't be killing my ears, I'm getting like nothing. And then this is heating up. Ah, Jesus. Yeah, that shouldn't be happening. Why are you like this? What have I done circuit-wise that would cause this to happen? This is the second time I've had the amplifier chip overheating. At least now we know that I'm putting voltage through it the right way, but there's not much to these circuits. So maybe it's the speaker it's a 4 ohm speaker. I don't know, 4 ohm and 5 watt, I think. So maybe maybe this just isn't enough to power it, because this would be like 750 milliwatts, and I put it with 1 to 100, sorry, 1 to 200 gain. If I put 12 volts through it, it should be able to drive the speaker a little bit more, but it keeps just heating up. So I don't know. I'm gonna have to do another. Yeah, it's not really doing it. And that thing's heating up too much, which is an odd thing. What in the world? Why is this happening to me? Ah, man, I just can't get these audio circuits right. Maybe I just need to hop on, like just do this, like. Just get one of these things. Or maybe take it apart and put it on something else. I could do, what was the one that they said in the article? I don't know what the cost of this thing's going to be, but let's just take a look. Where is that? It's all the way at the bottom. TDA 2050. Mono audio power amplifier board, $8. That's actually kind of expensive. 12 to 24 volt, 30 watt mono audio amplifier board. Maybe I do need to spend the $4 and get this, and then I can take all the components out of that and just install them on the top of the skull. What? Yeah, I need to figure out like what the different amplifier classes are. No, I'd take the components out and transfer them. The LM3886. Oh my God, that thing's huge. Look at the capacitors on that thing. Yeah, just completely redo a different circuit on more parts of it. I'm kind of running out of space though. Some of these look pretty complicated. For 25 bucks for, what is that? A 3-channel? Oh my God. I don't know. Yeah, maybe I just need to get something like this and run it in there. 9 to 17 volt, $7. Huge caps on the sides. I don't want them to stick out too much because then they'll get caught on stuff and explode. If I can't risk electrocution while using the speaker under normal conditions, yeah. PAM 8302, what is that one? That one's surface mount. Could I carve that into the skull? I don't think so. If I were to do that, we would use the one that I already have. It's the not this one. We had a schematic for, I looked it up earlier. I guess I closed the window, but it was the chip that was originally on the skull. And I have all of the other whatever it is, all the other components. 8402. That's gonna get me weird stuff, isn't it? There's stuff that would be against Twitch toss on Amazon. I need more than just the number of the chip. I need a couple letters. I guess this thing could drive headphones. It would be a much higher wattage or higher whatever. But yeah, just getting like the simple of the simple ones. Oh, it's a PAM? Okay. PAM. Wonderful. PAM. Didn't work. PAM 8302 does exist. Might have one of these somewhere. Maybe not. But yeah, these are all surface mount. So amplifier board, audio amplifier. Yeah, there's $8 for like a billion of these. 8406. I could just hide this in the skull. Just throw it in there secretly and just have all the other chips sitting on the outside. Made a Vox AC15 clone back in my day with Telefunken tubes. That's pretty cool. Tubes are too hot. They will melt the plastic. Also, I don't want glass sticking out of this thing. This is like a dumpy little speaker that I can hook up to the synthesizer. Yeah, I mean, I could do the surface mount stuff, but it'd be better to do some weirdo old school through hole thing and hook this up to the speaker initially, and if it works and if that doesn't get too hot, I can bring back the heatsink. There's still room for that in this circuit. Still room for the heatsink over here. I could hook all that up and just disconnect a bunch of this stuff. This one again looks pretty simple. I might do that. I might order one of the prime ones so I get it at least at some point, and just do this project in the background without you guys. We're going to consider this done. Every single design that I've tried has become an instant space heater. I don't know why, because I don't think these things are too fragile. I mean, yeah, maybe it needs a heatsink, but I'm not getting a lot of gain out of this speaker. That's the problem. I'm not gain. I'm not getting all the decibels that I think I should out of this thing. And I don't like it heating up like that. We're going to go to VCO tuning tomorrow. We're going to do more VCO tuning. And in the meantime, I'm going to buy some amps. This is going to start smoking. Because then I can just hook them up to 12 volts and the, what do you call it? 12 volts and the speaker to test them initially and see if they'll work. Because, like, this is a very simple circuit, so I don't know why it's fighting me like the way that it does. It's all this chip. This chip isn't very happy. Maybe it does just run hot. Maybe that's what those heat sinks are there for in the kit. It seems to have reached a thermal plateau, but it's also not drawing any current. It drew like 0.35 before. I think maybe it heated up and killed itself. Something else is dead. I also got in an argument with me once because I said gaming PC was a 99% efficient space heater. Well, power standards now, what is it, like 97, I think is the utter ideal? Makes gargling noises when I hook it up there. Could it be that the source is too loud? No. No, I think the LM386 is just not powerful enough. That gets like hot to the touch, like hurts you to touch. But it isn't getting much hotter than that. I don't think there's thermal protection on it. Turning it up and down, and it could just be my perception of it because it's so quiet, it just seems to change the tone. We could look at the voltage output, I guess. Do I have access to ground somewhere on the outside of this? I could press it into there. I could maybe do a stereo cable and clip into that. There's a stereo cable. Oh, but I can't output the speakers on this pin. Yeah, I can just plug into there, and then I need to get a good ground. Just see what the output looks like. Hey, I'll get a ground if I plug this in to the either board. I can just throw this on here. And there's a square wave output. We're not measuring that. We're going to look at what is coming through the amplifier here in reference to the same ground. Yeah, look at this. So let's turn off channel 3. And the output, just remind myself, it's pin 5 or 5. Yeah, see, it's not changing. There's something weird and wrong. Oh, no, I don't get it back. Where's input coming in? Input is coming in pin 3. That's supposed to be a sine wave. Yeah, there it is. It's sort of a sine wave. It's just not very well tuned. That's definitely an input, though. Why is it giving up like that? Oh. And that is... Oh, it's probably clipping, actually. Because that is 5 volts from there to there. Let's turn it to... Oh, why is this in... There you go. Okay, 1 volt peak to peak. Yeah, that's 1 volt peak to peak coming into the amplifier. Need to be smaller than that? Of course, I'm not getting any audio output now. I just get dead signal at a very high voltage. 1, 2, 3, 4. It's like 5 volts. So something is wrong. Something I've wired is wrong. I don't think anything's shorting out. Why did that fail again? Why do we keep failing? We keep failing at these things. This is very frustrating. I'm just gonna buy one of these speaker circuits and see if I can throw it into this thing. And then we'll keep the electronics on the outside, and maybe I'll clean it up, put a different chip in there. I'll put one of the 555 timers on the top or something like that. Throw in a couple of the extras and maybe just make it decorative at that point and have a circuit that I know works on the inside. I don't know why this has failed again, because by all means it should work. We have 1 volt peak to peak going into this thing, which means it's like a 2 volt audio signal. That's a little hot. But okay, before we totally zero in on that, let's see what this thing expects. And like with a gain of 20, we should have been getting a big sine wave output. 3D print some cool crimscrams. Yeah, maybe I could glue on some other cyber stuff. Well, I could do something with LEDs too. Figure that out. I really wanted it to just look like a skull with a bunch of electronics components sticking out of the side, which is not all that special, but it would have been a neat look. I don't know if I can still use that volume knob with the new thing. Analog input voltage, negative 0.4 to 0.4 volts. So VI is way hot. It's way, way too hot. Way too hot. I don't know if that means that if I give it a smaller signal, if it'll work. Do I have anything that can give it an audio signal? I guess I can do output from over here. Yeah, I mean, that's pretty much what I'd be doing. Is just, yeah. I guess the one that comes with the board will also fit in that spot. But here, I've got the Focusrite will output proper audio levels. So let's see if that gets it to be a speaker. It could just be that the Eurorack stuff is coming in way too hot and causing it to cut and distort. Where is the stereo audio cable that I had? Stereo cable, where did you go? Somewhere under the Project Explosion. That's not what I was looking for. There's a different stereo audio cable. One that is wrapped in fabric. And I don't see it. Where the heck is this thing? Okay, all right. Keep it together, brother. You can do this. I'm just disappointed. I'm just disappointed, that's all. Oh, maybe I put it back here. Noopers. Nope. Okay, maybe it's in the drawer. Over here. Nope. Double nope, triple nope. All right, I know where there's another audio cable. Oh no, that one's packed away. Nope, can't do that one either. Where is my other headphone cable? There was one sitting out on the desk here, and it was a right angle cable on one end. And I think, oh, I need the adapter though, because this is 1/4 inch. So yeah, I'll just get it off of the mixer. Yeah. Okay. So let's put this into the speaker and see what it sounds like. I'll have to play music, which will unfortunately go to YouTube and potentially blow up my house. So let's put that in there. Let's get something. You guys won't be able to hear this because you'll be able to hear what my desktop audio, but not the speaker. You'll still be able to hear it, but it'll just be playing, you know, what's already going through. No, I don't hear a damn thing. That should be absolutely blasting. What I don't get is how it can be drawing no current and still, like, blowing up. Yeah, that's just not doing it. Okay, so yeah, we still have a problem. I need to get one of those circuits. Boop, pause it. Okay, there's still, everything sucks. It's still terrible. I can't seem to get this right, and I don't know why. It's the frustration of electronics. You try to do everything exactly correctly, and there's probably some stupid mistake somewhere on it. This one was a much simpler, much easier to construct project. Yeah, it's the chip. The chip is just, I don't know. And I don't think I have a bad chip. It is always a possibility. What I should have done is this, put it on the prototyping board first. The only emote we need. Yeah, he Gonad enjoys the Mr. Waffles, was it? I forget what the cat's name was. This circuit is so simple, I don't understand how I could still be getting it wrong. We had a much higher volt peak to peak, so it could be that maybe we burnt it out by having too much input, but that would make it a very, very sensitive amplifier if that's what happened. I could have swapped a pin. There's all kinds of places you can fail with this kind of stuff. It's a little bit absurd. It should have worked just fine. It's a very simple circuit. I'm not going to keep messing with this. I got to cut my losses at this point. I tried to make a cool skull speaker on the outside of the skull, and I ended up making a cool skull heater on the outside of the skull. I just couldn't get it right. I will buy an amplifier board, and maybe that can just get thrown in to the thing. Do I already have an amplifier board? No, those aren't amplifier boards. I have like a VU meter thing, which would also be cool to put in here, but it's too big for the skull. VU meter would be kind of neat. Take a big hole saw and just take a big chunkus out of the side of this thing and then put a VU meter on it. I'm gonna go get the VU meter stuff. Hold on. Let me get these circuits and we'll see. I don't remember what happened to the driver board for them. I think they were in here. Oh, here's the driver board. Here it is. This is the driver for the VU meter. What happened to the gauges? Those things have been kicking around for so long that I don't know if I still have them in an accessible place. Let me check in here. This is all my Nixie tube stuff. All my ancient electronics. Joystick base. I don't think anything in here do. Well, it would be cool for Nixie tubes to stick out of the thing. I don't think it'll... That's true. I could maybe do the eyes, get rid of the sunglasses, and put the VU meters there. I don't know if they're in with these. They're not. These are all glass tube stuff. I've got all kinds of cool displays that I would love to get a use for. These are magic lights. They're really cool. And then I've got whatever this stuff is, the vacuum fluorescent numerical displays. These require a lot of electronics to get running. This is a very simple circuit that I was going to use to power a display on the front of the computer that I never got around to doing. And the rest of this stuff is like Nixie power supply stuff. These are really cool. These are Nixie power supplies that run them off of 5 volts. They bump it up to 60, and then you can use these surplus Russian chips. They're ceramic. They're actually not epoxy. They're ceramic chips. And they can switch the 60 volts to all the digits of your Nixie tube. Very much simplifies the projects. What was that? That was a little mote of dust that just flew away. Oh yeah, I need to put this in here. So that's not where the VU meters were. What happened to the VU meters? Oh, I'll have to dig around for them. I don't think I see any bins where they would be directly out here. Is that one? No. That's a big heavy screw bin. I got the glue bin. Yeah, because it would be in one of these bins over here. And I thought it would be in this one, but there's no VU meter housings in there. The driver circuit is definitely the right driver circuit. I just don't know what happened to the gauges themselves. They were cheap plastic things, though. They weren't very special. Yeah, okay, so this is none of the, these are all my 7400 series chips. So I wanted to use 7400 series in the modular synth stuff. I want to make that drum machine, the 7400 series drum machine. We have no software here. All right, so the VU meters are somewhere. I don't know where they are. It would be nice to be able to find them. I wonder if this keyboard works again. Spilled water on that. Only in the corner, but that was enough to kind of make it go a little crazy. Where are those meters? I gotta get all the way in here. I don't know, the voltage requirements of those boards too are a little bit wacky, so that might be a problem. Still, it would be neat to have a nice little, like, at least a mono meter on the side, with the possibility of going stereo in the future. But I might have gotten rid of them. Where would they be? Are they up around this stuff? I had a little case with them in it that also had some motor drivers in it, and I think I did something with the contents of that case, and I don't know what I did. I don't know what I did. What would I have done with them? Hold on, all the way in the corner, as I trip and fall and smack my head against my tool bin. And this stuff, this is all the camera stuff. The keyboard got wet because I had an open glass on the desk, and I went to reach for something and inevitably bumped the glass, and in just bumping it, it caused it to jettison a bunch of liquid that landed on the corner of the keyboard. It was a perfect storm of unavoidable things. Okay. Where would those have gone? Where would I put something like that? Maybe all the way down here? Oh, there's some more chips down here. I wonder if any of these would have been useful when I was building all these synthesizer things. A lot of these are memory chips. What are all these? Wait a minute. What do I have here? Yes, it is labeled Chad. That's what Roboz calls his chat. 74LS139N, a lot of them. Oops, I keep clicking the wrong one. 74LS139. 2-line to 4-line demuxer. What would I do with that? I don't think that would be functional anywhere. There's a couple of them in here. Just a couple. Motorola, it's a 6-pin? What in the world? Yeah, I got some weird stuff. This is from, like, research dumps of chips. Don't tell me this whole bottom row is 555s. It's not. CA3080E. Oops, I put a bracket on it. Delete, enter. Renaissance? Op amp, transcond, 1 circ, dip. What? What does that even mean? Two megahertz transconductance amplifier. Gateable gain blocks, which utilize the unique operational transconductance amplifier concept. Different input and single-ended push-pull Class A output. Jeez, I don't even understand any of that. Yeah, there's some memory chips with windows on them too. Those are always fun to observe from the microscope. Maybe at some point I can get all the focus rings in here and we can get real nice and close and take a look at all of that stuff going on in there. I didn't know I had these dumps. I have like a couple of these that I just found. Not what I was looking for. I was looking for VU meters that have been getting in the way for ages and ages. Cracked. Scan 34. These are as old as I am, these chips. These are ceramics too. And they've got the little erasing window in the middle. Yeah, a bunch of EEPROMs they use to store data. Research data. 3042, huh? 3048, MCP 3048. Yeah, I don't know how useful these chips are, but LM324, that's a good op amp. 747C, blah blah blah. Blank EPROMs, PROMs, and PLDs. Yeah, this is a cool little bin. All right, so what is this board that I have? If I can find those VU meters, I would love to use them. But what is the input voltage on this thing? We're a little close. That's a little close. AC, 9 to 15 volts. I got bad news for you, my friend. I don't have AC 9 to 15 volts to put into this thing. Yeah, this is some kind of like an amplifier circuit that would run the little VU meter arrow. I don't know if it'll work in DC though. I remember when I got these. A long time ago. Oh wait, it puts it directly into a rectifier? Does it actually need AC then, or can I just put DC in there? Can I just put 12 volts into this thing and have it run? I might be able to, although it might not reference properly and get weird results. Until I find those actual, wait, are they, hold on a minute. I might be back in the area where there are no bins. There might be stuff back here. There's some stuff. Oh. Come on, VU meters, be back here. Oh, that's a big thing of dust. It's part of my joystick project. A temperature sensor and a surface mount IC on a little board. What the heck am I finding back here? There's some weird stuff. No VU meters though. Power plug. All right. I don't know where they went. That's frustrating because this would be the perfect project for those things. Who's that? No, that's not it. Look around, see if I can find them. Sitting on stuff. A lot of dust. A lot of dust. Yeah, I'm kind of striking out lately with all these things. We'll try to have a win at some point soon. I'll schedule a win and see if we can't successfully do a thing instead of just all these unsuccessful attempts. But hey, you know, you kind of fake it until you make it, right? You just kind of fail at stuff over and over again until finally something goes together properly. That's all I did, and then all of a sudden I was doing stuff right the first time. It was a weird kind of changeover. What is this over here? Anything in there? No, it's like empty. There's like a wooden board in there. I got these flat bins that sit under the little project bins. Sometimes they got cool stuff in them. I think I got rid of the VU meter gauges, which is unfortunate because I've got the driver board still for some reason. They were pretty cheap though, and I think one of them broke. So it's not all that important that I find them. It would have been a cool thing to add to the skull. Maybe I could just buy something new. I hate to do that, but and as soon as I do, I'll end up finding the meters at the bottom of like a totally different bin, like in here. Yeah. They might be in the project trays that are on the other side of the shop. Anyway, I think we're done for today. That was not a success, and I don't know why that was heating up as much as it did. We were giving it DC 12 volts. We gave it 6 volts, and it even didn't like that. Yeah, it's the law of nature. As soon as I purchase the replacement, the old one will appear out of nowhere like magic. Thank you guys for joining me for this stupid Sisyphusian task of creating a skull speaker out of a perfectly functioning speaker. That thing was already working perfectly fine already, and we made it work less. I am going to end up... Oh, hey, Mesh Twitch. And Brawl. I am going to just purchase one of those speaker drivers and hook up the speaker and just see if it works. I don't suspect that the speaker would be the problem here. I have plus hooked up to plus and minus hooked up to minus, so I don't know why that would be going wrong. Maybe it is causing all the problems with these chips. Maybe I've been building perfectly functional circuits. I think what may have happened is that the input was a volt to negative a volt, and it can take plus minus 0.4. So I think we blew up the amplifier by sending it a little bit too hot of a signal, which is a thing that can happen, I guess. I just wouldn't expect it to happen in such short order, because, yeah, now it doesn't work at all. So, yeah, well, I've been sniffing so much copium, I don't know what it's like to be off of the stuff. So anyway, we're done for now. We're coming back tomorrow. We're going to do stuff lighthearted or end up scratching our heads at a VCO that I can struggle to tune. I think I just need to replace a capacitor in order to have it sweep fewer frequencies, and then we can move on to another piece of the modular synthesizer project. It'll be a little bit more light than this. I won't have to sit here soldering all day. Until then, I guess you guys take care. Here is my end card, END, it's dynamite, with all my social media stuff. I guess the VOD channel isn't in there. If you guys are interested in VODs, they are here. And yeah, I will catch you guys later. We're going to eventually build up a big catalog of VODs on YouTube, and I'll try to see if I can upload a bunch of stuff to it. So like, I don't know, I'll probably lose subscribers if I upload like 10 videos at a time, but I've got tons of videos. 3 a week for 6 years is a lot of video to upload. Who knows if anyone will ever go through all of that. But I'll put it up. I'll put it up because, you know, we've got a wealth of projects that I've done here and succeeded at. I'm just kind of striking out with this stuff lately. I haven't been able to tune up any of the VCOs. We finished with marbles, but it was a huge effort. But like these speaker circuits, I would expect a little bit of heat coming off of them, but this is ridiculous. I don't know what's going on. It's madness. So anyway, leave you with that, and join me tomorrow, same bat time, same, well, it's not really a bat